my health analytics, but I should sort of let you know I'm actually an accidental entrepreneur. Like many of you, I have been very active in professional bodies like ACM, IEEE, and so on. And I have been a techie and corporate like researcher both in the corporate applied research world as well as in academia. There was a very deep institute. I think Charlie went off. Okay, maybe I'm too loud. Okay. So there was a very, very unfortunate situation that happened in my life. Basically, I lost a couple of my close family members to breast cancer. So then it was almost like a calling, and I just quit my job and started Niramai 7 years ago. It was a interesting decision to make. So what it just tells you is there are different career options, but you can follow the heart, and you really can make a career out of it, whatever you're doing. You can do well if your heart is in there. That's all I can say in a sort of thought. So coming back to it, do you have a paper? So so let's just get to the topic, and hopefully you find it interesting. Then I just, So of course, all of us have seen medical images. During COVID, a lot of us have seen for different types, and I'm sure I'm talking to so many computer vision experts, and you would have seen thousands and millions of these, right? And when we talk about AI and machine learning, particularly AI and machine learning applications in healthcare, the primary area where this is really, really useful is in radiology, right? And radiology and AI, and there are like tons of data sets available, chest X-rays, with COVID labels, mammography images with labels and so on and so forth. But what has been found to help in a real setting is, sorry, I'm trying to stand and speak with Parliament. But rather speak here. Because I just have to hold and stand here. Yeah. Yeah, no, I think it is fine. Yeah. So basically, it helps in improving productivity of the radiologist, which is obvious, and the way it does this, obviously, it can be a simple assistant, we have to call as computer-aided analysis with assistive technologies or automated technologies. So there are different ways of using the AI itself in collaboration with the doctor. First and foremost, it has been proven to actually reduce the number of missed diagnosis or misdiagnosis. Because it's your...
Yes, yes.
Trouble your rest of the... not on Zoom. Do you have any questions for me? How many of you want to continue to do research? Right, I know you're talking to Guru. No? Okay, I love it. So, how many of you are scared that if you go to industry, you'll stop doing good work? Nice. So everybody believes that even if you go to industry, you'll do. Actually, it is true because especially in our area of obviously general area of computer science or any other topic, right? What happens is that there's so much happening around the world. Even if you are doing really, really mundane activities, you have to be innovative in order to be what they call it, cutting edge, right? Doing cutting edge stuff wherever it is, and you can, there's so many things changing, and you always have to be aware of, reading the latest paper in each of your own area of work and making sure that's incorporated into the product. So to stay current, even in the industry, you have to do research. Of course, if you consider research as publication only, not many industries may allow you to publish. But if you consider research as something, okay, as something that you can do innovative stuff and get the aha moments every now and then, that's definitely possible even in industry. I can vouch for it. I've enjoyed every bit of my life so far, doing research and of course also publishing. But yeah, I think it's coming. So let me get back to what it's fine. I think it. Thank you. So we're talking about different types of applications and benefits that AI and medical imaging is. Oh my God. So I'll skip this. Let's get to the real one. The main thing that I'm very excited about, especially in the last few years, is when as a technical person or a research person or a technologist, right, you see that technology is making the difference on the line, and somebody calls you and says, without this AI stuff, no, I won't have detected my cancer. Trust me, it's the most beautiful experience you get, right? And you save a life really with an AI. And that's what we have, been making me live every day in the last few years. Of course, I have worked on hundreds of projects before, obviously being head of AI for Xerox, being a techie was part of each one of those projects as well to some extent. But this is unbeatable, the kind of mental satisfaction you get, right? So what this basically means is that how AI can be used to bridge the gap between the haves and the have-nots, the developed and the developing countries, right? And the rural and the urban ecosystem. How many of you remember the stage 2 or COVID, right? Where, if you've looked at the TV and all of those, you will know that how the rural ecosystem was really suffering, right? There were many people waiting on the road to get into the ICU. There were so many, oxygen concentrators made overnight. There were so many smaller startups and so on building these oxygen concentrators so that we can keep people breathing. And this was because there's a severe shortage in infrastructure in the rural areas. And there's pretty much good ones in urban, but everyone flocks to this space. So this gets very, very, hard to handle from the scale standpoint. So when you use AI, and this is my premise to everyone, and of course I don't need to say too much to this audience, but it's important to take this message to everyone outside who are not really exposed to AI, right? That you can actually bridge this gap. How? In the rural areas, you can actually have automated AI bots, which is determining the priority, determining the risk, and then identifying the people who need to be brought from the rural areas to the hospital immediately. What you heard, like at the right time, the right people, and all of that, right? And that's really possible if your AI model is working and is able to work on real field conditions at the highest level of sensitivity. That is, you're able to detect any small abnormality and then bring them for a full detail. So imagine there's no doctor. Can you make a decision? So this is possible, right? The second thing is, of course, even in the urban setting, because every doctor doesn't even have time to have tea. I know they're super busy, right? And so for these people, the AI bots can be used to filter out people who are seemingly normal and mostly normal, and then you can actually make the assistant do the job for it, right? And of course, this is, I'm sure, is something that you would have written in the first paragraph or if you've actually published, but I'm saying this is real, right? And how do we make this real is my story I'm going to talk about. So as was introduced, we started looking at breast cancer as a problem that we want to solve because, of course, I had my own personal story, but it also is an important problem to be solved in the world today because it is the top cancer that is killing 684,000 women every year. This turns out to be 2,000 women dying every day unnecessarily. All of them, or at least most of them, can be saved if they were detected early. The only reason we're losing them is because we're detecting in stage 2, 3, 4, whatever, not stage 0, stage 1. And it is one of the most curable of all the cancers. And we all know if you want to detect proactively, you have to do these tests sort of regularly. So if you look at what kind of tests are available, okay, these are some more, available today, mammography is the default standard, and it is extremely expensive, and there are certain other difficulties of that. But the hand examination, which is called clinical-based examination, is the default standard in by the government of India or many other governments like India. And this obviously can detect only big lumps and so on and so forth, so it only can detect stage 2. So 98% of people are detecting their cancer by hand accidentally and then coming to the hospital for further diagnosis to see whether that lump is the cancer or not, and so on and so forth, which reduces the mortality rate to 50%. Every alternate lady detected with breast cancer is dying. Now, furthermore, when you sort of double click on it, there is also access issue because of the cost of the machine itself is 80 lakh rupees, or a real good mammography is 2.5 crores. How many diagnostic centers in India today can afford even an 80 lakh machine to be bought? And people, how many people are actually doing regular? So then what happens is that they're not able to, what they call as return on investment is low, so they actually charge more, and so it's a 4,000 rupees per test, and how many will actually pay 4,000 every year? Even because also feel we won't get cancer, so why do I have to simply waste my 4,000 every year to do this thing? So that's not happening, and so it becomes a negative circle. And also, in order to do the analysis, you need good doctors. There are only 18,000 radiologists, and so that's where we all have a job. Like, how can we make radiologists more scalable and feasible? There's also this other issue of mammography, because mammography is basically X-ray of the breast, just like chest X-rays and so on. So if there is somebody who has what's called a dense breast, which has a lot more fibroglandular tissue, then the whole breast appears white, and how do you find white? And so that actually reduces the accuracy. And so I may be sounding more like a doctor, but that's what I've been reading in the last 5 to 6 years, by the way, right? So, but this is the big problem. And this is something even FDA has realized and said that even the current methodologies are not sufficient. Go and do an MRI. MRI is 20,000 rupees. No way it can be a preventive screening. So it gets getting into a further difficulty of saving these lives. So what we did was, when I thought we have to solve this problem, I said, okay, why use X-ray? Because X-ray obviously increases the risk to cancer. So why do you want to do it every year and go on increasing the cancer risk for a person whom you want to save them? So we said, okay, is there any other modality that we can use to detect a similar abnormality? Of course, we looked up. There were a bunch of people, even in 1980s, who had said that, oh, they have used a thermal camera and look, they were able to find some cancer people and so on. So we said, okay, there seems to be something there. So started a project to get, take, because there's no data set, and we're discussing it, some of the frontliners here, so that there's no data set available which you can download and start experimenting. So I asked one of my doctors whom I was collaborating with for some, can I take a thermal image of a person who is probably a cancer patient? He said, yeah, sure, let's do for two people who's going for surgery tomorrow. And incidentally, we had a multispectral camera. So we took sort of in all the spectrum, and then we did see that, there was some real signal that was coming in, distinguishable signal that was coming in the infrared. Having said that, right, the kind of image you get is, I know it's looking very different from how it looks on my laptop, but the center one is the image that you get, right? And it's basically a heat map of the temperature on the skin. So basically, a heat map, like any physics heat map, I'm saying, not a thermal heat map. So basically, every point color represents a value and depends on how your max and min is to actually have the focus and so on and so forth. So what we ended up doing is, obviously, this is a place where we can possibly use a pattern-based analysis and so on and so forth. And so we developed machine learning algorithms to analyze these thermal signatures, not thermal images, but temperature maps, to generate the report completely automatically, saying whether there's an abnormality or not. And also we generated contrast enhanced images to mark the age of likely intelligently, so that the doctor can now look at the area that is, it's the same after the analysis, to say whether there's an abnormality by looking closer with, let's say, ultrasound or of course a biopsy. This is what we actually developed. And this was very novel because of several reasons. There's no structure in it. It's just a temperature map. So figuring out those, and for any health healthcare problem, which is specifically clinically oriented, I think it's not just about statistical modeling. It's also about some kind of a domain modeling is required. There's so much sort of knowledge that the doctors have created over time, and that has to be captured in some fashion. The third thing is there is huge bias or imbalance in the data, because thankfully, number of people who have cancer is much lower than the number of people who don't. But that's sort of not a good thing for people who are modeling, right? So how do we sort of handle this kind of 0.4% kind of imbalance, right? So in 100, you might find less than 4 actually. But that's the kind of issue we face. So that was another big issue. So several other challenges, but most important challenge is there's no data today. So we had to really start from scratch to collaborate with hospitals to take every data point that we need for building the model, starting from the two people that I mentioned. Of course, there were only positive patients. Then we had to get people who don't have cancer to come and take this image. That was also another humongous task. And what is not obvious is that there is no doctor today in this world who can look at a thermal image and confidently say, yes, there is cancer. There's no doctor today, right? Which means it is, of course, there are people who are guessing. Like there are about 500 thermographers who look at it, and for stage 3, stage 4, it's obvious and they'll guess it. But we are talking about lower, earlier cancers, right? So then we had to devise a way of identifying what is the ground truth for this, right? Because obviously this person has cancer, we know. But how do we know? We know because we are doing several other tests like MRI, mammography, ultrasound, and then tissue tests is being done. So, I don't know, maybe it's the necessity aspect of it. They said, okay, let's have a collaboration where we will do this test for everyone. And the same person goes through and does mammography, ultrasound, and biopsy for positive patients. And then we take that data to train them on. So it was a very, very detailed effort to actually even build the first model, using valid labels, I would say. So, and we do have a test now, which has wonderful features, right? First and foremost, yes, it is very accurate. I'm going to share the sense test with you shortly. We are able to detect much before a hand can detect. The smallest one where we know the size is 4 millimeters. 2 minutes more? No, sorry. No, sure. Yes, that I'm going to share about it, but makes you happy. We have 600,000 images right now that we have collected on. Yeah. And we are able to detect 4 millimeter lesions while hand can detect 25 millimeters. So it's 5 times smaller. And it's completely non-contact, non-invasive. And I'm going to show a small image of that. No radiation. We are just measuring temperature. How can we use just temperature? Yes, because when there's a cancer cell, there is higher mitotic activity. Of course, the science behind it, the medical science behind it is also important, right? There is higher multiplication of cell, which results in addition of glucose use, OTP, ATP, they say, and then there is an increase in energy that's happening, which gets transmitted to the skin. There's also higher vascularity. So we started missing cancers which are very deep because the heat did not travel to the skin. So we started modeling the blood vessel structure using the thermal signature. And so with that, we are able to detect, because whenever the cell is multiplying, there is higher food that it requires. So it comes through the blood flow and the velocity of blood flow increases. And so we're able to model those vascular structures as well. So we can do that without radiation, without any change in the density or age, because there are about 30% of cancers under 45 years. So we need to sort of to catch everyone because we can't afford to lose younger women. Definitely not older also, but definitely not young, right? So and most importantly, we made the whole thing, 1/10 the cost of what was existing there. And in many cases, we are able to do it free of cost as well. And last but the best is also the experience, right? Instead of sort of removing clothes in front of somebody else and then being touched and so on, we made it completely privacy aware, where she sits in front of the device, like a photography, passport photography session, but there is no photography, right? So you go inside, close the door, and then remove the clothes and sit in front of the device for about 10 minutes. You come out, the report will be ready, obviously, thanks to the command. So our mantra is no touch, no see, no pain, no radiation, which is actually something that is attracting so many ladies to do it. It's really about enabling everyone to take this test and without hesitation, without worry, right? And that is what it is able to do. So here is sort of closing the door and sitting in front of the device and just rotating to get all the views. Of course, it has resulted in a lot of awards and thanks. I also met Bill Gates. I met Sundar Pichai. I was actually in September invited to present this technology in United Nations General Assembly in New York. It's sitting next to the President of the United States. That's amazing. 2 weeks ago, I met the President of India, which is also a super experience, and she happens to be from India. So several things have come forward with this because, thanks to AI. Okay, well, good. Let's get into the whole thing, right? Hopefully, now my enough enthusiasm and eagerness to see what's happening. Let me sort of put like a disclaimer, right? It's really not about the specific algorithm because what I realized is that definitely algorithms are important, getting the best accuracy is important. But how do we make it work on the ground is the most important thing. And doing it in a way you will not hurt the person. But here you go. So the temperature is basically, of course, thermography is basically measuring the temperature on the skin. So you measure it, and every point here, is the, so every temperature gets a color, right? The rainbow palette, so on. So you see it this way. So this is good, but what happens from a manual interpretation standpoint? I think I briefly mentioned, these are two same people. There's 39 degrees as max, and next is 36. So what these tomographers used to do is like, what is the best max I have to use, when we have to do, so that I can start seeing some patterns, which is the right max, which is the right range that you have to use, what is the cutoff temperature above which something is hot. So these are all very, very arbitrary in nature, right? Visual in nature. So for example, there is this cancer here, but you can completely miss it. Whereas in this view, you can get it. So all this is super complex because we are looking at 400,000 temperature points. And so what we did was we made sure that the 5 views are taken, kind of 180 degrees view, upload it into our AI set of models. So it's basically thermalytics.com. Whoever has login password can go and upload and click, the result comes out. So you have to make it so simple for the end user. End user now is a doctor, and doctors are the least tech savvy, trust me, right? Anything you have to do it and say, just do one click and you should get. So we actually train technicians to just even upload, take the images and so on. There's several, about 20 plus AI algorithms running behind. Many of them we kind of had to do because we are looking at real data. First and foremost is the well-known phrase, no garbage in, garbage out. So you want to make sure is it garbage. So when a technician is trained and she uploads, so we have to do a lot of quality checks on the image, whether the right views are taken and so on. For that, the protocol for capturing the image itself, right? How to capture thermal image. There's no one else in India who is doing it, right? So of course, we looked at literature and then figured out what is the easiest way. Somebody said, put them in a chamber, temperature controlled chamber and so on and so forth. That's not going to work in a field if you want to do it. We came up with a protocol where we blow cool air for about 5 minutes. So there's a contrast enhanced, and then we start taking it. And of course, there are AI models to check whether when she is ready for taking it, so forth. And I really don't know how much time I have, but we also have to make it more explainable. So yeah, 15. Oh, good. So when you go to a doctor and say, yeah, here is the person who is positive said, why should I trust you? Why should I trust this AI model? I don't even know, like, there's nobody who's using thermal, so in my network, and how do I know that you're right? So then we have to say, okay, go ahead, verify it. Here is the marking. I showed you the marking in one of the images. Go do an ultrasound, you will find it. So we have to really create that trust by showing real facts on the ground so that, they can validate it or in their own methodology, using their own methodology. And once we start creating more and more such example use cases, and obviously nothing less than peer-reviewed publications. So publications in clinical journals and conferences made it happen. But coming to the point of explainability, we actually also were able to say, are we saying this is abnormal based on the cell division that's happening, vascular abnormality, milk duct issues? So we were able to go into semantics and also give different scores for that. So the quality checks obviously is a simpler problem because it's more like an anomaly detection issue. You can also say it's a class 1, class 2. So we use ResNet, typical ResNet. Obviously, the loss function had to be completely determined by us. And then we did get excellent tagging accuracy determining the view. Then also looking at the image and segmenting the right piece is important because we want young, technicians to be able to do this. So we've got excellent dice index, even above the inter-observer dice coefficient you will see, right, with some text. Next important thing that we did was also to identify what is a hotspot versus not, right? So we actually came up with a decision. The machine learning, but the decision tree, I would say, or decision function rather, where we are able to identify more like it's a function of a histogram, where you identify whether what is the temperature above which for this person, which is abnormal or not. So that was another interesting pattern that we had come up with. And then also we have new algorithms to extract blood vessel structure. So once we start looking at blood vessel structure, which are differential in nature, so what you're seeing is that there are lots of blood vessels on the right side and not in the left side. Obviously, she has blood vessels on the left side, but if you look at it from a differential perspective, differential velocity perspective. So the point is not exactly which algorithm, like what are the steps you will follow so that you can get there. So how do you model your problem in the form of known algorithms, let's say, or you can, of course, also have to innovate on the algorithm space, but more about how do you model the problem. So there were many, the whole structure had to be built from the beginning. So we used simple image processing sometimes, in deep learning sometimes, of course, simple traditional machine learning models sometimes, depending on the amount of data we had, amount of confidence in the labeling we had, and so on. So we ended up getting actually better accuracy than mammography also. So you see one person there, which has the equivocal sort of left and right dense tissue in X-ray, but they're able to identify that cancer. And this is something that every doctor really wants to see. Can I detect some people whom I've not been able to detect with my regular technology? So we also sort of worked with doctors to figure out what is the kind of report they want to see. So we actually had scores indicating the level of. We saw a blood report where they say this is the right range, and if you are not in this range, there is We need to sort of bring our thought process or our output into that format, because that is when the doctors will feel comfortable. That is when the patients will feel comfortable as well. So all this has actually resulted in 33 granted patents. And again, if any of you want to learn about how to patent and, um, not about making money with patents. It's about doing your work without somebody else's, objection. That's what mostly it is. But yeah, we have 11 granted. Japan, China, Singapore, Canada, Europe. And we also have to publish in clinical and also, of course, technical journals. Maybe I put only the here to show that of course, the algorithms were unique, but also the results that were got were compared with the final answer key, which is the tissue test. So every person comes in, take this test, and the same person goes through all the rest of the tests, including biopsy. And at the end of the whole question paper, about 300 patients, 600 patients, depends on the sample size that's relevant to the question you're asking, then external person will come and say whether these two matched or not. Trust me, when the test is being done, nobody knows the answer. Okay, so it's not the kind of testing we do in the lab where you have fully labeled data set and you'll do 80-20 rule and you'll show 99% accuracy in the 20. It's great to start with, but it's definitely not what will run on the ground. Sorry, I'm hurting some of you, but that's reality, right? That is the fun of working on real data. And yes, what was surprising, even in such a setting, we were able to get 100% asymptomatic sensitivity. That is, we did not miss any cancer that was found by either a mammogram or confirmed with biopsy. And of course, you can't have 0 false negative, false positive. So it turned out to be 8% false positive rate, which is pretty okay. So what we're saying is 8% people may need additional tests and they may say no, there's no cancer. And what was also interesting is that we compared this with mammography, we ended up getting much higher sensitivity than mammography as well. So a lot more women who were not able to detect in their breast were able to detect it. So this thought would be interesting for those of you who are thinking about machine learning in medical imaging. So there is, of course, the problem creation. We want to determine what is the problem you want to solve. It's not just like breast cancer screening is a problem, but what would be the sub-problems that may arise there? And for each of it, is there a model that we're thinking about? And making sure that you don't have sort of bias in the data that is that you're collecting or you're given, and making sure that there is veracity in the labeling is also very, very important. And like I briefly mentioned, lab and in-house testing is great. That's only a beginning, right? But maybe that's an ending for some of the publications, but that's the beginning for any field deployment. And after that, you have to give the tool in the hands of a doctor, in the hands of the end technician, and then measure the efficacy. There again, you can do what's called as retrospective testing or prospective. But finally, there should be some clinical body, regulatory body, which will actually say, yes, this is working, right? And you can use it officially on people. So we fortunately were able to, a lot of the understanding of what needs to be done, but with mentors or with experts in the field, able to get not just India clearance, but also in the US and Europe. We just sort of made in India very clear to make AI-based medical imaging going and getting used in other parts of the world. So far, about 170,000 women have benefited from this test on the ground. We've detected thousands of cancers which wouldn't have detected earlier. We commissioned in about 8 countries, India, Kenya, Turkey, Sweden, Dubai, Abu Dhabi. The hospital and lot of camps that we have conducted, and of course we have collected thousands of rural people there. We did it free of cost. We also have a big kind of incorporated into a small tempo traveler so that it can go into the real corners of India. And we have very top names here at CG, Apollo, NRN, all of them using it, as well as, Googles of the world, who can, who have already started providing this to their employees. That's, and so many women who didn't know that they had issues, got, benefited. I think I'll skip these things for the want of time. But basically, we also made it very flexible to use, either in a hospital or in villages, in a district hospitals, any other place. If you have to make it, I thought I'll make it interesting for extended, but maybe I'll skip it. So basically, I kind of end with this slide, where for collaboration, I know there's a lot of academic institutions here and industrial sort of charities, because I feel we've just scratched the tip of the iceberg kind of a thing, right? There's a lot more we can do. I feel that we have probably stumbled upon a new method of detecting abnormalities in the body. We are already seeing it happening with the Bill and Melinda Gates Foundation grant. We were able to figure out abnormalities with it very accurately in Ghana. We started seeing some benefit in head and neck cancer, some benefit in diabetic food, all the detection. So there are tons of other diseases that we will be able to detect without touching the person, without seeing the person. And I think there can be an ACM you can walk. So I definitely thank you. Thank you, Geeta, for that very informative and wonderful talk. Audience, do you have questions? There's a question.
Thank you. This is great work. The what value of false positives is acceptable will also be dependent on how rare the disease is. So, if something is 1 in a million, then even 1% false positive rate will give hundreds of more false positives than positive. So, like, could you say, like, among the ones that are termed positive, like, what fraction are actually they have cancer?
So basically, among the ones who are term positive, how many of them have positive predictive value, right? So it depends on how many. It's right. It depends on how many. Are you doing it in a hospital setting where people have walked in with a symptom? So then obviously our positive value CPD is much higher. So that if maybe even for example 20% PPV is considered great because you're leaving out 80% of people that need not come here. So I had this funnel, which actually answers your question. For example, in Punjab, we did about 15,000 people screened in villages. 300 of them had been brought to the right. In that, there's still some of them are still going through the follow-up diagnostic. Some people are saying, "Kuch nahi hai, better," all that is happening. But only 10% of them have been confirmed malignant with biopsy and started treating. So 30 people already see just with one device. So you see what is the equivalent number with our previously used method. The clinical risk examination is 1/4. The same 25,000 women screen, less than 10 people detected. Obviously, we have not created cancer in any of them. It's just they were running around, right? And that is what kind of helps them.
So if I'm understanding this right, this shows that it's better detection in asymptomatic people. That would be the inference.
Yeah, definitely better detection is asymptomatic. Symptomatic also we detect. But yes, we focus on asymptomatic because symptoms important that they better get to it, but they usually go because they'll start seeing something wrong. But it's important to detect before stage 2 if you want to save them for 50 years after that. Otherwise, we lose them within 5 years.
Thank you so much. This is great.
Yeah. Yeah, say your name.
So I am Prerna Mukherjee from JNU. I'm faculty at JNU. So ma'am, I have few questions. You mentioned the false positive rate. What is the false negative rate?
So you have many statisticians here. False negative rate is 100 minus sensitivity. When I say sensitivity is 100%.
What's the frequency of getting this test done? Like for mammograms, there is some frequency, right?
That's also interesting. I mean, like, many of the doctors and patients kind of ask this. So, okay, I'll give you the actual answer, but then because we are all innovators, so basically, it's like you can never say when cancer will appear where, right? It's mostly a guesswork, right? So just like mammography is done annually, we would recommend do this annually. But we went one step further. We give scores, just like a diabetic, you do a glucometer test or something, right? So imagine there's a litmus paper you dip into the blood and it gives some color shade and you have to guess with it. That's what thermography is now. But when we put in a number, like the glucometer says 100 or 300 or 90, like you know whether it is, what level, how close you are to the boundary. So let's say you're 150, then you need to sort of reduce sugar and do the test more often. Same way. When we give a scoring, if the scoring for the person is close to 0.5, probability that if it's above 0.5 has a probability of. So 0.4, then we say why don't you do it in 6 months? If it's 0.3 or 0, then you can even do it for 3 years. Or I mean, it's the amount of confidence you have in the thing, but generally we say once a year or once in 2 years.
And does the thermogram have any possible side effect over the long run?
Absolutely. It is, see, all of us have gone through thank you for asking this, right? So we have this sort of thermal gun, infrared gun. It's exactly that. It is not throwing any energy on the person. Because our body is a source of energy. Like, we're always 37 degrees Celsius, irrespective of whether we are in Kashmir or, here, right? So that is what it is. Just measuring the radiation that is coming in from our food. So absolutely no side effect. Yes, we blow cool air for 10 minutes, but it's only 21 degrees Celsius. The chill hoga, enjoy the chill.
So are you planning to also extrapolate this to other sorts of cancer?
Yes, 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 yes.
Detect metastasis?
Yeah, so, okay, what it doesn't detect is if something is wrong inside the brain or lungs or, blood or something that it can't detect, right? Because there's no soft tissue or you can't model the thermal signature. So, yeah, so that isn't.
Thank you.
I think we are running out of time. I see the signal. So
No, we can have a couple of.
yeah, okay.
So wonderful talk, Sita. I actually follow your work a lot. I'm also a budding entrepreneur. I'm a very naive.
You want to tell your name?
So yeah, my name is Diksha Bhartiya. My startup is called Genomic Solutions. We work on genome informatics solutions for genome testing. Since breast cancer is an inherited disorder, and I just wanted to know that when you have developed this model, have you also incorporated the data of the family history, the patient demography, and all those features which might also have an important, importance in this particular thing?
Yeah, that's a good question. So actually, I didn't go into the sort of the report format a bit, but basically we give different scores. Is it because of inflammation? Is it because of vascularity? Is it because of milk duct closure? Also have an ensemble score. So, so this audience, I don't have to define ensemble. Usually for the doctors community, ensemble is a joint, the combo score, all that I keep telling. Anyway, so the ensemble score actually uses the other patient demography information because we are AI, so we better take whatever information is available.
Exactly.
Right now, I don't have genetic data. Obviously, it's something that we have to incorporate because not many people in India do genetic testing. The BRCA positive one, you may be aware, BRCA1,
So
BRCA2.
because we are doing that, so I was thinking maybe
Yeah, I
a
mean,
venture for
definitely we
collaboration.
can, any of the people have done genetic testing, we can incorporate that. Right now, we take family cancer history, age, menopause, all of those sort of, well-known risk factors are taken into account to generate a final answer.
And I have another question. So for the patient that whom you are going, who's going for this thermal screening, are you also advising the other, because this runs in family?
I missed the last
So basically, the patient who's going for thermal screening and you identify some measure or you score the person to be breast cancer positive. So do you also sort of advise them for screening for other patients, because other family members, because this definitely runs in families. So there might be huge possibility.
Yeah, usually this happens by default. So they say, oh, it's more like, no, I like this experience. First, she will actually bring her mother. Then the mother will say, oh, this is very good. You have to do it. So it's more in terms of the experience which enables it, not the scare of the risk. Actually. actually. But yes, we work with doctors to say that whenever you're treating a cancer patient, get all the family members do this. But it's more evangelization actually.
Yeah, because it will be very interesting to see that what kind of thermal pattern comes with what kind of mutation
Right.
and correlate both of them.
Yeah. I don't have that information right now, but it would be good if we are able to get.
Thank you. Thank you.
More questions. Really, there's no time I can take it on much time. Yeah.
PK faculty at IIIT
Yes.
Hyderabad.
You're
Um,
wonderful on the stage. Yeah.
Thank you. So I have two questions, one technical and one non-technical. The first technical question is, so what are the thoughts around privacy for this? Meaning I'm more so the algorithmic privacy, not necessarily the physical world privacy. My second question is, you, you told about your success stories. Can you tell one or two challenges and stories that did not work out the way you thought it would work?
Sure. Thank you. So regarding the data privacy, obviously, when we actually start asking for regulatory clearance outside India, it becomes more now. India is also going towards that. So what we consciously did was initially we didn't even take the name and phone number or email ID of the person. So that way, we are not even keeping any private data because I just wanted to um, be clean about any of the sort of the guidelines that are there, and we don't want those to be affecting. So we were only giving patient ID, AS001 and all that. Then people started saying, I don't know whether it's mine or my mother's. Oh, I have to look at the age and figure out if it's my report or because they don't know the patient ID. So then we actually do consent forms saying that I will take your email ID password only for sending you the report and making sure your report gets. So that's the only private information we're taking. But as far as that is only at the sort of the tool, client tool end. But as far as the cloud is concerned, to do the analysis, it's completely anonymous. I showed so many images and we don't even know whose images it is, right? Even the lady will not be able to recognize her own image in many cases, right? So it's already anonymized data, right? So that is what is giving us a lot of power. For example, when we work with Dubai, Abu Dhabi, they're super conscious about the privacy regulations in the area. So we worked with them to develop a client tool where they'll take all the inputs of the name, phone number, and then map it to a number. And they'll give the anonymized number to us. We also don't know who the patient is when it comes to the cloud. And we have a reverse mapping that is happening in the tool. So we had to do some of these things. And cloud is available in different zones. Like in AWS, we right now work on AWS. So that way we run in the same country zone so that they don't feel like inter-country transfer is happening. So some of this, so we are GDPR compliant, HIPAA also compliant. So these things are necessary. To your second question, I think for any entrepreneurship, right, there are a couple of things. So one is your belief in the idea that it will work, and it should not be a dumb belief or blind belief, right? As again, all of us being scientists, we have to prove to ourselves that it is the right idea. I mean, it's very hard because you love your idea, you love your baby, you always think it's right. But you sit on the other side and say, okay, if this is happening, then I need to fix it, right? Or is this result that you're getting correct or not? So being a critical judge of your own results is very, very important. So once you have that, you have a strong belief in the idea. You have to hold that belief irrespective of what others say. I think it's so important. First few years, we were only getting a no, 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 no. I mean, I've never read this in my book, my MBBS degree. Why should I? Boss, my I started using Dr. Geeta a lot more. I was not, though I have a PhD, I was not using the word doctor, but I started using that more because then you get some recognition in front of the doctors. They agree to talk to you. I mean, trust me, it's a different community. It's different community. Are there any doctors here? They're like, everyone is dirt. it, there are many doctors who are beautiful, who are very, very open, but many of them, because obviously they're saving lives, they're God. Definitely, I honor them. But so this kind of a thing, right? You're not even from any of the medical community. How can you tell me what I have to do, to treatment? So these things, I think those are the main challenges. And I didn't want to refute them. I said, yes, I am not from your community, but I want to work with you. Tell me, what should I do? What should I prove to you so that you will accept this and start using it? I think the first few years of rejection is the main thing. So I went back and said, okay, they want me to publish in Lancet Oncology. Somebody like trust me, in India, there will be very few doctors who are published in Lancet Oncology. Lancet is like Atlas, those kind of thing, like literally huge, merit for publishing. So some doctors threw at me like this, you have to publish in Lancet Oncology. I said, okay, you have to make it a policy in India. I'm a small, person sitting in. How can I change the policy? But I said, okay, this is what? Okay, I'll do it. Let me figure out how to do it. I think this kind of saying, okay, this is what will make it work, and I have to find a way of doing it. And finally, in 2023 January, we got a Lancet Oncology paper. That was like really for me, right? And it's amazing. Now I know what to put in front of the doctor, right? And probably that slide was purely made for doctors. I should have made a new one for you. But I put all those logos which doctors appreciate. And there is a conference that happens in San Antonio, Texas, just breast cancer symposium. It's called San Antonio Breast Cancer Symposium. About 7,000 oncologists come there. Right? Everyone from all over the world comes. It's an amazing conference. The person who invented chemotherapy comes in there, like Pura White Daddy and all. It's super, okay? And every year, last 5 years, we've had a poster. I haven't made it to the paper yet, but poster there. And this one is absolutely a record from any Indian working in breast cancer. These kind of things I go and tell the doctor, right? Some of them say, okay, fine, there is something in it. It's like that Indian mentality is like that. Firangi log, so anyway, so I had to actually also get US FDA for that piece. So these are some of the challenges. Main challenge is getting the trust of the doctors to start using. Yeah. Maybe I will close with one last question. Yeah. You decide between you who want to.
Take one.
Yes. I keep spamming them with list of publications. Initially, I was not putting it up on our website because they were like these crazy guys who are trying to copy and claim it is same. But I have now put it up. Anyone can look at our publications, nirame.com/publications. But mostly we are focused on clinical in the last few years for the obvious reasons. Yeah, over to you, ma'am.
Hi, ma'am. My name is Anisha and I postgraduate. First of all, this is an amazing talk, like very interesting. So I had one small technical question. So you mentioned that the temperature range for hotspot detection changes from patient to patient. So my question was that change or that optimal value, are you obtaining it like before training the model, or is it like chosen on the go when a patient is diagnosed using the tool?
We have a model which predicts, which takes the temperature distribution and predicts that threshold. And that is obviously improvising
On the
every
go.
time. Yeah. And we try to predict only those where there is either a benign or malignant. Benign is like looking like cancer, but it's not. So those also we take, and then we have trained that model. And yeah, there are several things when you actually put it up, you can't learn on the go. And these are some regulations. But yeah, hopefully, but yeah, thanks for the question, and it's a simple answer. But hopefully, this has made at least a few of you want to, feel more. You already wanted to do some startup, but maybe you got more courage to do it. But one line about that is like, of course, I didn't know anything about finance, stock options, and I'm now running a company with 100 people right now, right? And it's really what takes you is the goal that you want to achieve. And if that goal is really beyond yourself, like basically you're helping people and so on, you'll really find a lot of people helping you, learn things which you don't know, go towards that. So all the best, and thank you so much for listening.
Thank you. Thank you very much, Dr. Geeta, for the excellent talk, and thanks for all the questions and making it interactive. There's a lot of, it's very inspiring to learn about you. Thank you. Thank you for your time. So just a couple of announcements before we break. So we have a coffee break now. Since we are running a little bit behind on time, I request all of you to come back here by 11:15. That gives almost 17 minutes or so. We have the lightning talks starting. So please try to make the coffee break quick, and let's be back here by 11:15 sharp. Coffee is served right outside the place where we had breakfast. So let's meet again at 11:15.
Okay, quick announcement for the students who are attending PhD clinic. You already have your schedule with the slots, and the slots are essentially numbered tables in cafeteria. So go to cafeteria, find your slot at the given time, and you'll see your mentor sitting there. Thank you.
So for the poster presenters, a quick announcement. We will have half the posters giving the lightning talk today, and the rest will be tomorrow. I would expect all of you to come here anyway and be ready. We'll call out the names in the list, and we will stop at the midpoint today. And then whoever gets to do the lightning talk today will put their poster today, right? That's where we'll cut off, right? I hope that's clear. So let's meet at 11:15. Thank you.
So people, if you want to hang your posters on the poster boards, you can go. If you want to do it now. That is Karthik.
Okay, welcome back, everyone. We will wait for another couple of minutes. Some more people are joining, and once they are here, we'll get started. Okay, so let's get started. Here's the way will run this session. So I will request all the poster presenters to come and assemble in the front. Right, you can come here and sit or stand near the front of the stage, and I will call out the name, and then you have to come up, use one of the mics. Oh, you're saying there itself? Okay. No, I think it's fine. Let them come onto the stage. The timer will start. Each one of you will get 60 seconds. And after that, Shubhankar will make some noise. And that is a hint that you have to stop. We are going to be very strict about this. So please adhere to the time. And, again, just to reiterate, the goal of this is that you should be able to make an elevator pitch or a lightning talk, in other words, where you can capture the interest of the audience about the research that you're doing, and hopefully encourage them to come to your poster to have a more deeper conversation. It's more like an advertisement, right, or a teaser. So you don't have to go into detail explaining your problem or the solution. Say what it takes to get people curious and interested to come to your poster. That's the goal of this lightning talk session. I hope that's clear. And so if I may ask all the speakers to come and assemble here. So the first is Akhil, whoever can come in the front. You can stand in front of the podium and use that mic. Yeah, yeah. Let's wait for people and then we'll the time. Yeah. You can use the podium mic. Okay, I will start. Let's start with the names. Shubhankar, hope you have the timer ready. All right. So first we have Akhil. Yes, please. Your time starts now.
Yeah, good morning, everyone. So I myself, Achilles, and I'm presenting, I have a poster upon the work of effective conjugate fraction dimension. So effective dimension or constructed dimension models the rate of information in an object. And in this line of study, we study infinite binary strings. And conjugate fraction dimension is the same notion if you use something called the conjugate fraction representation of a string. And in this work, we show the surprising result that if you use the conjugate fraction representation, you can get, theoretically, you can get a slightly higher density of information in the string. So this is the work. I have the poster up. Please do come and visit. Thank you so much.
Thank you. That's well in time. Good job. Okay. Next we have Banashri.
Hi everyone. So I am Banashri Karmakar from IISc Bangalore. I am here to present our work on risk Superfast MPC with a friend. This got accepted in IEEE SNP 2024. So traditional MPC setting mainly considers two kind of traditional secure multiparty computation mainly considers two kind of setting, the honest majority and the dishonest majority. In case of honest majority, majority of the parties are honest, and in case of dishonest majority, the majority of parties can be dishonest. So dishonest majority captures the most realistic scenario, but it is computationally expensive as compared to the honest majority setting. Moreover, it is not able to give us the most desirable properties like GOD and fairness. So this paper basically considers a new setting to construct a protocol. In this setting, along with a dishonest majority, the presence of a semi-honest TP is considered throughout the entire protocol.
Your
And-
time is up. Banashri.
Yeah, to know more about our contributions, please visit our booth. Thank you.
Thank you. Next we have Chandrima. Chandrima Kayal. Yeah.
Hello everyone, I am Chandrima Kail from ISI Kolkata and I work in analysis of Boolean function. In this work, we mainly have focused on the composed Boolean function. We have a Boolean function f and another Boolean function g. This circuit computes the composed function f composed g. Now it is very natural to ask when you compose function, what happens to the complexity measure? This is a very well studied and well understood problem in this area. Although we don't understand for two classical measures, randomized query complexity and approximate degree, how they behave under composition. In this work, we have focused on these two long-standing open problems, but we ask a weaker question. Can we solve these problems for some classes of function? And we made some partial improvement towards the main open problem. So please do visit our poster. We can discuss in more details. Thanks.
Thank you. Perfect timing. Neetu. Neetu K.
Hi, myself Neetu. So you all know in today's world, the data has become so huge that it is very important to have a proper communication between the storage and the processing units to have improved performance. So with our in-memory computing based design, we come up with a latency improved version of in-memory computing design that actually improved the results so much that the energy delay area product has been improved up to 84%. So I request you all to come and visit my my poster for getting more details. Thank you.
Thank you. Thank you, Neetu. Prashanti SK.
Hi, I'm Prashanti, a PhD student from IISc. I'll be presenting our work that was submitted and accepted to Sigmatrix last year. So here we study the characterization of deep learning training on the edge. So why should you train on the edge? Edge devices are getting more powerful. You also have a lot of different use cases like federated learning and continual learning. What are the challenges with doing this? There is a huge parameter space and the architecture is very different from servers. So one interesting result, the system default power mode that NVIDIA suggests is not Pareto optimal in terms of time energy trade-offs. So to get more details on this work, please stop by my poster. I'd love to talk to you. Thank you.
Thank you. Next, we have Dhara Thakur.
Hi all, I am Dhara and this is a joint work with Nirdhara, Harshil and Saket and it appeared in ISAC 2023. So here we studied graph modification problem where we are modifying graph by deleting k vertices and we want the number of distinct eigenvalue of the remaining graph should be less than equals to r. And the results we have obtained is like for certain special cases we are obtaining hardness result and for those hardness we are obtaining FPT results. So if you are interested in detail, please do visit my poster. Thanks.
Thank you. Next, we have Zaya.
Hello everyone, myself Zia Umayya. I am from IIIT Delhi and this is a work in joint collaboration with Dhruv Malik, Devashish Kosai and Piyush Kumar Sharma. So we know that Tor is a popular anonymity and anti-censorship tool. It has more than 2.5 million daily content users, but it is also being blocked very frequently by different nation states like Russia, Iran and many other countries like China. So in this particular paper, in this study, we studied for around 1 year with 1.25 million measurements over the tools that are being used to quarterly transfer Tor traffic. And those tools are known as pluggable transports. So we studied around 12 tools and we have multiple findings about the whole PT ecosystem. We have made it reproducible. You can use the QR code to get to the code. And come visit my poster so that we can have some meaningful discussions about the measurement studies throughout this work. Thank you.
Thank you, Zaya. Next, we have Asim Srivastava.
Hi everyone, I am Asim Srivastava from LCS2 Lab IIIT Delhi, and I work in the space of building blocks of conversational systems in the space of mental health. And regarding the work on the screen, you can see response set guided reinforced dialogue generation for mental health counseling. In this particular work, we have worked on generating responses in the dialogue system for mental health. We have worked on a novel methodology using TRL, basically transformer reinforcement learning, and that's what we will be discussing when you will coming to our poster. Looking forward to meeting you guys there. Thank you.
Thank you. Next, we have Sunil. You will do it tomorrow? Okay, we skip to the next one. Ananya, you.
Hello, I'm Ananya Upasna from IMSC Chennai, and this work is based, so this poster is based on a work that was accepted in SODA last year. So we give approximation schemes for some partial covering problems. So these are basically approximation schemes that give a better approximation factor than was previously known, albeit an FPT time. And we also study the one of the partial covering problems, which is maximum coverage with a different perspective. So here we are trying to fix the number of constraints, but we try to approximate the number of objects that are used to cover these constraints. And in fact, this particular approximation algorithm that we give is the best possible approximation possible for this problem. So if you're interested in this result and you want to unravel the jargon that I said, please do visit my poster. Thank you.
Thank you, Ananya. Siddharth Jaiswal.
Hi, everyone. So if you care about biases in different sorts of systems like text-based gender predictors, what you would like to see is that the systems are fair to all gender types What we see here is that for non-binary speakers, these systems don't really work pretty well. So to fix this, we have contributed a new data set. We've also audited existing systems for their biases, and we have proposed some mitigation solutions. If you want more details, please come to my poster today, and I'll be happy to have a chat. Thank you.
Thank you. Abhirama P.
Hello everyone, myself Abhiram. I work with Dr. Anand from IIT Jodhpur. So I'll briefly present this paper titled Answer Mining from a Pool of Images towards retrieval-based visual question answering. Suppose if I ask you a question, do the rose and sunflower share the same color? You have a preset bias that rose is red, sunflower is yellow, so they are not of same color. But based on these set of images, if I give you an yellow rose and yellow sunflower, here both of them share the same color. So not only the preset bias is responsible for answering the question, the given context which comes from the input multiple images, this also makes contribution towards the final answer. So we present a data set called RedVQA and a method to solve this problem. So you can drop by the poster if you have further more questions. Thank you.
Thank you. Actually, it's very impressive. Most of you are sticking to the time, and Shivankar hasn't had to make noise. Soumya Jyoti.
Hello everyone, myself is Shobhajyoti Dev from Jadavpur University. So today I'm going to present my work, a couple-based ensemble of CNN for malignancy identification in breast histopathology and the cytology images. So there are some samples of the breast histopathology and the cytology images. So here I have mainly explored on the couple-based ensemble model for the performance increasing of the malignancy identification in the cytology histopathology domain. So due to lack amount of data, I have also extracted some ROIs by some fuzzy membership functions. And after that, I have extracted some probability distributions value. And finally, I have predicted the images by some voting techniques. So there are some samples of the breast histopathology and the cytology samples. And in the right side, I mentioned some results of analyzing some CNN models, also some ensemble models. So if you want to interest in the cytology in the histopathology event, please visit my posters. Thank you.
Thank you. Next, we have Indradyumna Roy.
Hey everyone. So locality sensitive hashes are techniques which retrieve the approximate k-nearest neighbors given any point in sublinear time. So they are widely in use by all the major players in tech industry today. These are customized to the notion of similarity or distance function, but unfortunately for the recent more exotic scoring functions, we do not have any LSH, such as earth mover distance, chamfer distance, or as we deal with here, hinge distance, which are widely used across various applications in text, images, and graphs, and so on. So in this work, which got accepted in Europe as a spotlight, we deal with an LSH. We come up with an LSH for hinge distance, and we do it via Fourier transformation, which allows us to term this as a cosine between two Fourier feature maps. And now that we have, since there's already a well-known LSH for cosine, we now have an LSH for hinge distance. So please do reach out to me for more discussion on this. I'm sure you will enjoy talking about it. Thanks.
Thank you. Next, we have Ulas A.
Hi, have you ever wondered how Facebook manages to tag photos of its users and friends very accurately? Keep wondering. I'm not going to be discussing about that. Now, I know what you people are thinking. You must be thinking, I wasted your time making your brains process some unnecessary information. Yeah, exactly. I'm going to be talking about how to process unnecessary information and how not to do unnecessary computations. Now, if you're really wondering very curiously, like what exactly all this is about, please come and visit me about my posters. By reducing the number of iterations to actually reach the poster, I'll be discussing about that as well. What do you think all of this poster actually has over here? This is like unnecessary material. It appears like that. Adapt yourself to it, okay? I see you guys. Thank you.
Thank you. That was fun. Next is Ankur Nahar.
Hello everyone, I'm Ankur from IIT Jodhpur, and today I'm going to talk about my research cache-in for the user of experience that is traveling in the car. So if you are watching any video and you are getting annoyed by buffering and all, So we are going to address this by consider the diversity of India, different regions of India. And obviously, if you hate buffering during travels, then please come and visit my poster. I'll give you a solution. Thank you.
Next is Debashri Das.
Hi, I'm Debashri Das from IIT Kharagpur. So I'm developing a work where actually we see whenever the driving behavior is going bad, we mainly accuse that whether the driver is at fault or some other reason is that. So for that, we have developed an edge device where we have actually lightened the computation and utilized the resources very carefully, and that gives the on the edge solution like a lighting solution to understand who is at the fault, whether it is the driver or some other. So please drop by my poster for more details. Thank you.
Thank you. Next is Rajdeep Mukherjee.
Hello, everyone. I'm Rajdeep Mukherjee from IIT Kharagpur. Today, I will be presenting my paper ECT-SUM, which got accepted at EMLLP 2022. So what are we trying to solve here? We are basically trying to solve the long document summarization problem in the financial domain. What do we propose? So we propose both a data set and a new method. So as far as the data set is concerned, this is the first long document summarization data set in the financial domain. And what's interesting is there is no manual annotation involved during this entire preparation process. And finally, yeah, we also propose a new method which beats several of the much hyped large language models as well, especially on the factual consistency metric. So please do visit my poster for more details. I would happy to take questions. Thank you.
Thank you very much. Nimish Mishra.
Good morning, everyone. I'm Nimish, pursuing my PhD with Professor Devdeep Mukhopadhyay at IIT Kharagpur. And in this work, we are one of the first to demonstrate a new attack vector using fault attacks on high frequency system of chips. So rather than focusing on processors and memory, as prior works do, we do it on the system bus, which has not been traditionally protected against attacks. So definitely we had some POCs which we can discuss offline in the poster, but the main impact of this work has been that we were able to break one of the commercial implementations of trusted execution environments that is deployed across many devices in the IoT hemisphere. And we worked with Lenaro and others to fix it. And so we'll be presenting this work at NDSS next month, as well as at Black Hat Asia in April. So thank you, and please drop by the poster for more discussion. Thank you.
Thank you. Stanley.
Hello, everyone. I'm Stanley Samuel and currently a PhD student. This is our work, Symbolic Fixed Point Algorithms for Logical LTL Games, presented at AAC 2023, where we tackle the challenging problem of infinite state reactive systems, where given a reactive system, for example, a robot that wants to reach some target destination while avoiding some obstacles, which is also a temper specification, we synthesize a controller which is correct by construction that ensures all behaviors satisfy specification. We implement these techniques can be viewed as logical LTL games. Our approach is implemented in our tool, Genesis LTL, with around 206x speed up. You could meet me to know more about this later.
Thank you. Gaurav Thakkar.
Hello everyone, my name is Gaurav Thakkar from IIT Kanpur. So in the current scheme of things, what happens is that fabrication of hardwares, it is outsourced. So we design the circuit and we outsource it to the foundries to be manufactured. So what it introduces is that it is possible for malicious entities to get access to this design from the third-party foundries, because the designer has no access, who has access to this particular design. It is possible for them to sell this IC into the black market. So my work is how can we use functional synthesis to stop this particular attack? Even if the attacker has access to this design, he is not able to pirate it into the black market. So if you are interested, like how can we use functional synthesis here in the hardware domain, please come and visit me on the poster. Thank you.
Thank you. Suman Mighty.
Good morning, everyone. I am Suman Maiti from IIT Kharagpur. Our work targeted attack synthesis for smart grid vulnerability analysis, which was accepted and presented at ACM CCS, overcomes the limitations of the pre-existing works focusing on grid vulnerability assessment like the MAD IoT and Black IoT. It does so by developing a two-stage attack synthesis framework, where at the first stage, we use a falsification-based counter-example guided tool called STRIO to find the most vulnerable time instance of a power grid operation. This is then followed by inducing false data injection attack vectors on the grid sensor measurements with the help of a trained reinforcement learning agent during the identified time instance to make the attack vector more lethal. Also, the RL agent ensures that the attack vector remains undetected by the bad data detection units present in the grid, thereby making the attack vector stealthy. And in the second phase, we spoof the GPS signals of the phasor measurement units in order to obfuscate the grid's actual behavior from the operators and preventing them to take mitigating actions. And we have also provided effective countermeasures against the proposed attack model. So please visit my poster for further details.
Thank you. Kirti, okay.
Hi, everyone. So before introducing myself, everyone will be using encryption algorithm as we are using WhatsApp, right? So what we are trying to do is, you may have a feeling that, okay, it's encrypted and hence there is no vulnerability. So what we are trying to understand is, even though our systems are encrypted, there can be something called fault injection attack, where attacker can induce fault and compute the secret key. So nothing as we have thought is secured is not secured. So there has been some techniques to find formal verification, which prove that it's functionally correct, but still the excess vulnerabilities depends on the implementation. So here we design a high level structure. So this is not just one work. I have combined multiple works here. So which find vulnerable operations from software implementations of block cipher. And we have also designed security metrics to protect this. And we have also introduced countermeasures to protect vulnerable instructions from software. So for more details, you can obviously visit the poster and see how the things are. So this is completely a compiler framework, and it gives you the protection from any block cipher implementation. So myself, Kirti, and I'm working with Dr. Chester Rabairo, IIT Madras. Thank you.
Thank you. Next, we have Nihar.
Hi everyone, myself Niharanjan Sahu. I am from IIT Bombay, PhD student. So here I will be presenting my work that was accepted at ACL 2023. Title is With Prejudice to None, a fused multilingual transfer learning approach to detect social bias in low resource languages. So our target was to detect social bias from social media posts related to Hindi language only, but we went on to explore if it can be, the approach can be translated to other low resource languages in the framework of detection of social bias. So we tried it with two other languages, Korean and Italian. But we saw like the approach works well with every languages. But if the like we try this approach with the same language family like Hindi, Italian, English, they mostly comes under same language families. And if we use English data as the like kind of original data and do the transfer learning on Hindi and Italian, the performance boosts a lot as compared to Korean. But it can be applied to any languages also. So for more details, you can visit me at my poster. Thank you.
Thank you. Saraswati Nanoti.
Hello everyone. I am Saraswati. This is joint work with my advisor Nildhara Mishra, and this was presented at last year's MFCS. So here we have a eternal vertex cover game. So we have a n vertex graph and there are k many graphs and there are attacker and defender. So the job of an attacker is to attack an edge and the job of a defender is to move at least one guard across the attacked edge. And the minimum number of guard required such that the defender wins, that is the defender can defend infinite many attacks, that is called as eternal vertex cover number. And we have shown exactly which bipartite graphs satisfy that the eternal vertex cover number is same as the vertex cover number. So for more details, please visit. Thank you.
Thank you. Next, we have Suman Raj. After this, we have Lokendra, and we will stop there for today. The rest of you can go back and we'll continue this tomorrow. Suman Raj.
Good morning, everybody. So this is Suman Raj, and I'm a PhD candidate at Indian Institute of Science. So here we are trying to work on a problem statement where we look for solutions if drones can actually guide visually impaired and what are the challenges involved in that particular situation. So over here, I'll be explaining one brief architecture and one methodology, and related to systems research, what kind of problems come up if we try to work on such real-time deadline-driven vision-based tasks. And there is a cool video demo as well. So please visit my poster. Thank you so much.
Thank you. Lokendra.
Good afternoon, everyone. I am Lokendra. So you all have heard about the cryptocurrency. So the technology behind this cryptocurrency works is blockchain. So my work basically enables multiple type of blockchain users to communicate with each other, and that too without the presence of third party. So for more detail, please visit my poster, and I'm happy to share every detail of the work. That work basically published in CC Grade 2023. Okay, thank you.
Thank you very much. It's excellent. Everyone actually, most of you stuck to the time. That's really impressive. And as I said, the goal is to be able to capture the core of your work and generate interest among the listeners so that they can come and you can have a more deeper discussion at your poster. So thanks for today's speakers, and the rest of you who didn't get the opportunity today, you will be doing this same kind of thing tomorrow. And some of you, I think, have not yet submitted the one slide PDFs. If you want to, if you have a poster but you have not submitted the slide, you still have time. If you can email them to me by today evening, I'll be able to incorporate your slide for tomorrow as well. So we do have some slots available. And instructions for those who spoke today, you can bring your poster and set it up outside, just outside the cafeteria and outside this auditorium here. There are volunteers who can help you with fixing your poster if you need any help. And I would suggest you put it up during the lunch, before you go for lunch, put it up, and then it can stay till the end of the day. Right? If there are any questions, you can ask me now. We have a couple of minutes before we can start the next session. Otherwise, you can always come and reach out to me if you have any questions. Okay. All right. So I think we're done with. Can stop sharing this one. Thank you, everyone. We'll move on to the next session.
So good afternoon. This particular session we have particularly done by the organizations who are looking for PhD students for recruitment. And so that will be really interesting that we have people from academics as well as industry also. So let me first invite Kushal Saha from Sitara University. Yeah.
Thank you so much, Shekhar, for this kind invitation. A very good afternoon to all of you. It's a great pleasure to be here, and I'm truly impressed by all the presentations I saw today morning. I am from Satara University, which is not just a university, but a truly unique initiative, not just in India, but the whole wide world. But before getting into that, let me just briefly introduce myself. I did my BTech and PhD from IT Madras in 2005 and 2009. After that, I did a postdoc from the Weizmann Institute of Science in Israel. After that, I was a regular faculty in IT Delhi for 5 years. Then a regular faculty at ISAR Bhopal for 4 years. But I thought government job bahut ho gaya, let's try something different. So I spent 2 years in 2 startups. But वो corporate culture इतना समझ में नहीं आया. So then I came back to academia, and I have been at Sitare since the last 1 year. So why am I calling Sitare University a unique initiative? The most unique feature about Sitare University is that the education at Sitare is completely free of cost. Rehna, khana, padna, everything is completely free of cost. However, the criteria is that the students must be bright, which means that they must have a good score in JEE mains, and they must be from very poor background. So the average annual income of our students is around 1.5 lakhs per annum. They are like kids of farmers, and truck drivers and people from really, really rural areas, but extremely smart students. For me personally, it was actually a kind of a shock to see that such bright kids can also come from such backgrounds. So this university was started in 2022. Our campus will come up near Indore, but currently we're operating from Lucknow. And as you can see, our founder is Dr. Amit Singhal, who is also an ACM fellow. And he was the one who was responsible for Google search for 15 years. So all the Googling that you do, he has literally built it out of his own hands. So our first batch was taken in 2022, and we had 23 students. Last year, we took our second batch, which had 44 students. And in the coming August semester, we are planning to take around 150 students. And we provide only CS education, primarily because, our goal is to uplift these students out of poverty. And currently, if you look at the job market, most of the jobs are in the IT sector. But yeah, in the future, if you see manufacturing, electronics also coming up in India, then we will also open up in those domains. But currently, we are providing a BTech in computer science. Our curriculum is also truly unique. We are a 4-year program, but our courses are completed in 3 years. You may ask, how is that possible? The answer is that we do not teach all the physics, chemistry, all the workshop, and all the thermodynamics to computer science students because we don't really see that is necessary for most of them. We teach them maths, whatever is required to pursue, algorithms, machine learning, and stuff like that. But our courses are completed in 3 years, and they are completely industry focused. The 4th year is to be spent completely in the industry. So we have already started talking to industry partners. Our founder himself is an investor in more than 60 startups in India and abroad. Right from the first year, students start getting paid internships. So for example, last summer, all our 23 students went for paid internships to Bangalore, Bombay, Bhatinda, and various parts of India. And all of them had a, truly amazing experience. Who is an ideal faculty for Sitare University? Somebody who loves teaching. So, typically almost all the universities in India, because of NIRF ranking, are running after, some publications in some, some index journals and stuff like that. We do not have any such thing because we don't charge fees from our students and we are not after any kind of rankings. So we don't really worry where you publish, what you publish. That is totally your personal thing. We are caring about teaching. That's a interesting dichotomy in India that most universities exist for teaching, including IITs, but all the rankings and all are based on publication, which is a very weird kind of a situation that exists in India. So we don't have that problem. We are completely focused on engineering. I don't think we will ever even apply for this NIRF ranking because we don't really care for that. So for us, it is necessary that a faculty who joins Sitare has to truly love teaching, not just as a chore to be done because it is paying me money, but truly you have to care for the students, and you have to have a very deep empathy for students, truly care for their well-being. Of course, you need to have a strong hold on your subject matter. You may not have published in some truly great journals, but your basics have to be, very, very strong. The mathematical details, the coding, being able to do hands-on exercises with the students. That has to be done, very, very well. And of course, you need to be, you have to be willing to learn new pedagogical techniques. So we are not a conventional university who just teaches, somebody goes to the classroom and gives a lecture, comes back. No, we are not that kind of a university. We truly believe in innovation. If you talk to me, I can share more details with you later on about what kind of new and novel techniques we are using in our teaching techniques. And we also have a lot of mentors from US, from Stanford University, from Princeton, from Cornell, a lot of these people who are guiding our faculty to develop these new ways of teaching to make sure that the students' learning is very, very effective. And the result of all this, you may be hearing that in colleges in general, the attendance is very poor, students don't come to classes. But in our institute, the attendance is always 100%. Unless the student is sick or has some other, issue, that's a different thing. But otherwise, on a normal day, our attendance is 100% because of two reasons. First of all, our curriculum is very specially designed to ensure that whatever we teach is relevant for the student. We don't teach arbitrary, useless stuff. And our teaching methods, our teaching style is designed in such a way that the students actually take an active interest in the course. And what are the faculty attractions? Why should you join Sitara University? The first thing is that our students are very committed to learning and they are very, very sincere. As you know, because they are very, very bright and they come from very poor backgrounds. So learning these things is the only way they have to jump out of their poverty. So the teaching experience here is truly amazing. I have taught at IIT Delhi, I have taught at ISR Bhopal, but the pleasure of teaching at Sitare is uncomparable to anything I have experienced ever in my 10 years of teaching career in other places. And this I'm not saying just to advertise Sitare, but it is actually a fact. You will, if you come to us even for some time, spend a few days with us, you will get to see that the experience of teaching at Sitare is completely different from any other university. The teaching load is usually much lower than other private universities. In other private universities, it's like 16 hours around, 15, 16 hours. Here we have 10 hours. There is also financial support to pursue research abroad. So, typically, as I said, I have been talking a lot about teaching. So you may say, okay, I did a PhD. What about research? So although we do not really look into your publications, we don't really care whether you publish in, A star or A or B or wherever. But if you want to do research, we will support that wholeheartedly. So let's say you have a collaboration with some university in the US and you want to spend the summer over there and you are unable to get some, grants from somewhere, we will sponsor your flight tickets and your stay in the US during the summer. And that is written on in our brochure, which I'll be giving to you. I have this brochure printed. I will be sharing with you. Please do make sure that you collect it. So I would like to emphasize on this point that although we are focused on teaching, we primarily look into your teaching skills and your subject hold for hiring. But we understand that having done a PhD, you would like to continue research, and the same holds for me. I am also continuing my research. So we do provide financial support of all kinds to be able to enable you to do that. And of course, if you want to commercialize your product, no better place than Sitare, because our founder himself is invested in 60 odd companies. And he would love to have, the 61st company from a faculty member at, Sitare University. And there is zero publication pressure, as I mentioned. And the most important thing, is that you have an opportunity to make a significant contribution to society. Imagine that thousands of students who are coming from such poor backgrounds, with an annual income of less than 2 lakhs per annum, after, 4 years at Sitare University, they start earning 12 lakhs, 15 lakhs, 25 lakhs per annum. Imagine the kind of prosperity that it will bring, not just to their families, but to their village, their society. It will be a truly transformational movement. So with this, I end my talk. If you have any questions here, I would love to answer. Otherwise, I'll also be available near the poster area where I would love to interact with you. Thank you so much.
So I now invite, yeah.
So we don't care for the NIRF or for any kind of this QS NIRF rankings, and we are fully funded by our founder. So we don't have to go to anybody for money, and we don't even seek money from our students. So we don't have to impress anybody. So
You don't seek money from students means the fees is low.
Zero.
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 Sorry, I missed your initial.
Yeah, zero. It's completely free of cost. Rehna, khana, padna, sab completely free.
But teachers are paid, no?
So the students are selected through JEE. Teachers are paid. I am paid more than what I was paid at IIT. So if I was, yeah. So let me also clarify that. I think I did mention that. So you will see it in our JD on LinkedIn that if I was, let's say, a faculty at IIT today with whatever experience I have, I am getting paid more at Sitare than what I would be getting paid at IIT Delhi or IISER Bhopal. So free doesn't mean that, that teachers are not funding the university. Okay. It is being funded by the founder. I am getting paid more than what I would be getting paid at IIT Delhi. So, let me clarify that completely.
Okay, again, I apologize, I came late. Who are the founders?
Yeah. So founder is Dr. Amit Singhal, who is an ACM fellow, and also he was responsible for Google search for 15 years. So he was an ex-SVP at Google from till 2015. So the university is completely funded by him. So we don't have any publication pressure because we don't have to impress anybody. And students will come because of the kind of backgrounds they are coming from, and they pretty much don't have any other opportunity. Even if they go to, let's say, even if they get selected at, say, IIT or NIT, they have to pay a decent amount of money for either the hostel or, something. And these people don't even have that much money. So that's why we don't have to worry about all those things.
How do you pick your students?
Yeah, the students come through JEE mains, and typically our JEE mains cutoff is around 93, 94 percentile. So that's how we select our students. Economic background, the criteria is that their annual income has to be below 3 lakhs per annum. So the average is around below 1.5 lakhs. So some of them don't even have any income, and they are just surviving. They are just surviving on government aid. A lot of our students are also of that kind. So it's a truly unique initiative. You will be really touched if you spend some time in the university. It is nothing like anything you would have seen anywhere else.
But
that much I can guarantee you.
Not many students can get through JEE without money, right?
So that's why
coaching classes.
So these students are really very good. So these students are really, they are not, random guys roaming on the village streets. They are really very sincere, very good students. It's amazing. It's really amazing. You must come there to see it for yourself. Okay. Thank you so much. Thank you.
So as I mentioned, it will be available in the poster area for further communication. So let me now invite Flame University for the presentation.
Hi, everybody. My name is Kaushik Gopalan. I head the Center for Interdisciplinary AI at Plain University. I'm here with my colleague Samritha, who's back there. And we're going to talk about recruitment needs at Plain University. I joined Plain in 2020 after about a decade as a scientist at the Space Application Center. It was a long overdue move to academia, and I'm going to talk a little bit about why I made that move. So Flame University, you might not be aware about it. It's at Pune, which is genuinely a good city to live in. It's a nice place. Not all of your institutes might be able to see that with a straight face. We have a vast variety of disciplines. We are primarily an undergraduate program. We offer degrees in psychology, economics, literary studies, business, all kinds of business, finance, marketing, HR. We have environmental science, and we have three primary tech-based courses. One is applied math, one is data science and economics, and the third one is computer science, which is what we're hiring for here. We have a bunch of experience and highly qualified faculty. We have international collaborations, we have very well equipped facilities. You can see some of the photos in our poster, and we have a very vibrant and interdisciplinary faculty community. We're hiring, our hiring focuses on theory, systems, AR, VR, computer vision, artificial intelligence, machine learning, also applied math and statistics, but we're open to applications in any areas, even beyond these, any areas of computer science. We are open to applications at all levels of seniority. So if any of your advisors seem unhappy where they are, please ask them to get in touch with us. One benefit that we have compared to government institutions is that we don't require post PhD experience at the assistant professor level. So we have no like on contract positions. So in your PhD and through your pre-PhD experience, if we can make out that your expertise and your competence, then we would be happy to make an offer without any post-PhD experience. We have a competitive salary. It's a private university, so we don't have fixed scale. So depending on your profile, it should usually be equivalent to or better than the 7th pay commission pay scales at the central institutions. We have grants which are again equal to or better than what IIT faculty get through their CPDA. So depending on how you perform, like those values are also flexible. So it can become substantially more than what is offered by the IITs. In addition to that, we have avenues where you can apply internally for funding, for travel, equipment, other research expenses, right? And I mean, in addition to publications, we offer recognition for contributions in the academic community. So that those could be like media pieces that you do, or like open source software that you create. So we value not just publications, but all kinds of academic contributions. In terms of teaching, the average teaching load that's expected is about 6 hours a week, because we offer a very niche and unique and expensive undergraduate program. So the focus is a lot on quality rather than large class sizes. So our class sizes are often under 30 students, very rarely over 40, and never above like 60. And anything above 40 is incredibly rare. So, I could kind of keep saying how good Flame is, but I also wanted to say something specific. So I wanted to kind of give you my perspective, how my day or my week is at Flame, because I mean, if you're applying somewhere, you want to see how it's actually like. So we recently started the AI Center, and a lot of my time goes towards, setting that up and getting that running. So in this given week, my first meeting was with a design professor. We're working on a software tool together. My next meeting was with a computer science student and a physics professor working on a linguistic problem. So, when we say interdisciplinary, you're going to see in the next minute what I mean by that. My first meeting on Tuesday is with a tech startup CTO, trying to figure out collaborations, and then I have classes 8 hours a week in the semester. Wednesday, I'm working on a project with a literary scholar on using AI tools to develop low-cost reading material for visually challenged students. So basically, tactile material and Devanagari Braille text, right, for visually challenged primary school students. I have a project going on with a sustainability expert. On Thursday, I'm meeting with a person who works on AI in finance, in the financial markets. On Friday, I'm working with a dance professor and a computer science professor, Samrita, on automated recognition and classification of dance videos in Bharatanatyam. And I have a meeting with a historian on improving OCR for handwritten Sanskrit texts from the 17th century. So that's the kind of breadth that our academic community have, and those are the kinds of interactions that we are capable of having. I used to work in ISRO where if we have one satellite, we have like 15 teams working on that satellite. And everybody understands that it's good for your health and well-being if you don't step on the toe of another team. But this kind of breadth here in academia has been really valuable for me. And if you think it's valuable for you as well, then please come and talk to us. We would be happy to give you more details. Any questions?
You mentioned about the founders.
The founders are from a company that, called Enam Capital, which did the IPO for Infosys back in the day for Axis Bank. So they're big financial market players. Our university has been around since 2007, so it's been around for a while.
So there are opportunities in industry also apart from academics. So let me invite Shankar from Intel.
Hi, good afternoon, everyone. So I'm Shankar Balachandran, and I am at Intel. I work for what is called the Process Architecture Research Lab. So it's Bangalore based. So we're a group of 20 people working out of Bangalore. Before this, I was a faculty member at IIT Madras, and I switched over to the dark side. I started wearing dark T-shirts since then. So the Process Architecture Research Lab is a 7-year-old lab. Before this nomenclature of Process Architecture Research Lab, we used to be called the Microarchitecture Research Lab. We were both in the US and in India. And the MRL side of the US wound down, and we became complete owners for all the research problems related to architecture in general and microarchitecture in particular. So our focus is on problems that are relevant to both academia and industry. So we have a lot of deep collaborations. I'll talk about that a little bit later. But the problems that we look at are relevant to both Intel and industry in general, as well as to academics. So currently our research focus is on a few different areas that I've listed on the left. So core microarchitecture and architecture are our bread and butter. So if I tell you Intel, that's probably what you'll think of, right? The processors that Intel makes. So our processors are in data centers, laptops, base stations that are there for wireless processing and so on, right? So it's a wide spectrum of processing that Intel processors are on. And some of the problems that we look at, so Intel is a big organization, it's an ocean, right? So the process architecture research lab is 20 people. So what do we really do? We work on what are called the H2P problems, right? The hard to predict problems. A lot of the work in processors, right, is speculative in nature. So you have a processor that runs in sequence. Functionally, it has to do whatever the programmer asked it to do, right? You cannot violate that. But there is a lot of speculation that happens internally. So you might have heard of branch predictors. Caching, for example, is also something which gives the same functionality without being exposed to the external world and so on, right? There are lots of features which are inside a core which gives you the performance that you need. And the H2P problems are hard to predict problems. So, for example, in caching, what kind of data patterns should I prefetch, right? Or in branch prediction, what kind of branch directions should I take, and so on. So these are really hard problems. So when I say hard, right? So I was talking to somebody in the morning also about this. So branch prediction was at 99% accuracy even 20 years ago, right? And it moved to 99.5% a long time ago, right? There is still this 0.5% of branches that we cannot predict. And so someone may ask, what is the big deal in going from 99 to 99.5% accuracy? It's a 0.5% accuracy increase. But I look at it as it's a half the reduction in errors. And with errors, the penalties that are attached to these errors are humongous. So that's why some of these problems are really interesting. So we don't want to waste any cycle that is in the processor on work that will be thrown away later. Because a lot of the work is speculative in nature, right? You have to optimize for performance, you have to optimize for energy, right? So all of that. So that's the H2 problems that I was talking about. So there is a subgroup that looks at AI and ML. So they look at all the way from math to silicon to compilers all the way up. And they do hardware software co-optimization. So they look at algorithms, they build chips, they put them as accelerators next to cores and whatnot, and the whole shebang. There is also a subgroup that looks at system software and OS for data centers and cloud. These workloads are very different. So their data footprint and even code footprint are very, very large compared to other programs. And memory management is a big problem. So Intel doesn't want to give dollars. I will not represent Intel. Generally, industry does not want to give away dollars to other companies in the same industry, right? So memory is one piece of the cost, and cores are another piece of the cost for any data center, right? So anything that saves memory cost, right, from the computational side itself is pretty interesting to look at, right? So can we do things in the compute side and reduce the requirements for DRAM that you have in your data centers? So that's an interesting problem, and it's a very hard research problem. There's of course a lot of dollars that are there, but without the dollars also, right, as a research problem, these are very interesting. So these are the kind of problems that we look at. We have very deep collaborations with academia, both in India, in Europe, and in the US. We fund universities. I think in the last 5 years, we have funded maybe 20 different universities across the US, Europe, and India, multiple, maybe tens of millions of dollars in the last 5 years or 6 years. We publish heavily at top places. If you're in the systems area, you probably recognize ISCA, Micro, and HPCA. If you're in the VLSI design kind of space, Date and DAC probably rings a bell. So we also publish at CVPR and so on. Being an industry lab, of course, patenting is also something that we do regularly. So in the last 5 years, I think we have had 60 plus patents across these areas, right? So I want to talk a little bit about research philosophy that we have. So the first thing is the academic pyramid, right? So I was in academia. So generally it is about, oh, I want all my research and papers. It's the bottom, right? That's your base. And then you have patents, maybe, right? Some universities care for it. Most of us don't care as academics. Sometimes you go and build companies and you build products and whatnot, right? So the pyramid is narrow at the top, or probably non-existent at the top, right? For many academics. So when I was a faculty member, I had my publications, I had some products and patents, right? And some companies with which I worked and so on. But the top was really narrow. So when I say invert the academic period, right? Pyramid, what I meant is, so we look at what impact can we do to products and which can which can bring performance, area, power, all of these things that are important for processors, right? So that's the truly important thing for us. And in the process, we get our papers and patents. So papers and patents are important, but it's not the thing that we go after. So what that means is our research is not blue sky research, right? We are very fairly grounded on practical problems that the industry faces in terms of what manufacturing we can do, in terms of what power delivery can the customers take, right? All of these things, right, dictate what kind of research we do. And the problems are then very meaningful and very interesting research problems. Like I said, so we have many academic collaborators who are also interested in the same set of problems as we are. And we have like weekly calls with them and so on. So this is a very enriching place for any researcher. So I'm a full-time researcher there, but so I'm pitching it to a community here, which is mainly students. So we have internships, research fellowships, full-time positions open. So I have flyers that I'm carrying with me. So I would like and thank you if you can take these flyers and put them up on your notice boards and give it to your departments and so on. So I'm carrying a whole bunch of them. You will have very able mentorship. So our group is headed by Srinivas Subramani, who's an Intel Fellow. So Intel Fellows, there are 100 people all over the world, right, in the history of Intel Fellows. So one of them is in India, and he's heading the lab. There are several of us who are well published. We have got our best paper awards, test of time awards, and things like that. So you'll be under very able mentorship for any of these positions that you are in. So I'm going to put up a poster myself with the permission from Shekhar, and you're free to come and talk to me about this one. Thank you so much. If you have any questions, I can take them. Thank you.
So all of you are enjoying Bhubaneswar, I'm sure, and particularly this nicer campus. So though our hosts don't want to advertise themselves, but there are openings and opportunities in nicer also. So you can contact Haritra and Shubhankar if you are interested. Apart from this particular session, we also have two sessions in the evening, everyday evening. So one from the industry and one from the academics. So today evening, we'll have a special session by Microsoft for opportunities in Microsoft. And tomorrow evening, we'll have a special session by Plaksa University. So just to conclude, I just want to invite Karthik to tell you about today's Microsoft session.
Hello, everyone. I'm now not wearing the program chair hat, but I'm wearing my Microsoft hat and speaking to you. So as Shekhar mentioned, we also have a session, dedicated session, where I'll be addressing all of you today evening at 7 o'clock. And they told me that since we are the dinner sponsor for today, we can say that none of you will get dinner unless you attend my talk. I'm just kidding. But having said that, just to give a high-level picture right now, I mean, I don't need to talk more about Microsoft. You all know, all over in the news these days, especially with our investment in OpenAI and the leadership we are taking, especially in the AI space. But Microsoft itself is a much broader spectrum across the breadth and depth of computer science. Microsoft has had a very lasting impact with lots of researchers within Microsoft Research. We have a lot of Turing Award winners at Microsoft, and cutting across, like I said, all areas ranging from theory. In fact, tomorrow's keynote speaker is from Microsoft Research, from the theory group. Hardware, we collaborate with Intel as well. Hardware, cloud, AI, vision, even bio, quantum. So, you know, the entire spectrum of computer science, you name it, Microsoft has its presence over there and leadership. So, and there are open positions, both in India and abroad. I will talk a little more in the evening session. So please do join that. We have both a Microsoft Research Center in India as well as a substantially big development center. So there's a whole wide variety of career opportunities. But yeah, just wanted to take this opportunity to advertise for my session in the evening. So looking forward to talk to you all at 7 p.m. Thank you.
So thank you for joining this session. And like today evening session, dinner is only for those who attend. So now lunch is there for all of you because we attended this session. So let us break for lunch. Thanks.
A quick announcement. We have our next session starts at 2 o'clock. So we have almost 90 minutes. So I would encourage you all to use this opportunity to also drop by the posters that will be put up now. And you got a glimpse of what posters were presented. So whatever resonated with you, want to have a follow-up conversation, etc., please use this time as well. We have a good 90-minute break. Thank you.
Hello. Hello, everyone. Good afternoon. I know it's post lunch, uh, but we have very interesting panel and a keynote by our OCCW winner. I'm very happy to see female participants. As you can see that the event now we have is a ACMW committee event. So that's a women committee. And we name our this event as ACMW Annual Summit for Women in Computing. So I welcome all the women in computing, in tech, as well as the supporters. So we have, uh, first we have a panel and then we will have a keynote. Uh, our ACMW Summit houses two events, right? So I just wanted to and give a brief that what the woman wing does, right? So you know that you all are aware about ACM, right? I feel many of you are already members of ACM and taking the benefits that we get from ACM, right? So ACM is the world's largest educational and scientific computing society. Now we have this ACMW to support, celebrate, and advocate women in computing. And ACMW India takes the task forward by growing ACM community, in particular focus with, of course, empowering women, right? And how do we do it? We provide some social professional support to women in computing by promoting the participation and professional development, by organizing various events where women can come together, network, celebrate, and interact. And we also recognize their contributions in the technology field by giving awards. So a little statistics is of the engagement of women in ACM. So we have 3 ACMW professional chapters. When I took the data, it was 3. Now we are 1 for professional chapter. And ACMW student chapters across India are 43 active chapters. So I just want to brief about the activities that in particular ACMW committee does in India. So this is our event list that we organize for specifically for girl students as well as the PhD scholars and professionals, women professionals throughout the year. And I would like to just go through some of the glimpses of these events. So very happy to share that last year or the current year is the 10th year of our ACMW committee incubation. So, and we were sharing it with ACM Women Europe also. So we had Indo-European joint event. It was an online event and that was the very good interaction of 2 different zones. This is one of our flagship event that is the grad cohort. I feel many of you might be aware, or if you are not, then this is an event where we invite research scholars, students, as well as faculty members, and it's specifically for the people in women in research. So last edition was at IISc Bangalore. Some glimpses. So it was a 2-day symposium with lined up keynote speeches and seminars. A very good networking opportunity. We do a lot of events for the undergraduate girls also. Like we have this national level hackathon. Last edition was at PSG Coimbatore. The hackathon is run or conducted in 3 rounds. First 2 rounds are online, where we call for proposals. Then we evaluate the proposals. The second round is online presentation, where we take presentation of the students. And the third is an offline round, where we invite 10 teams, that is 30 girl students, to a location. And they have a 24-hour coding round there. And for this, we give them a travel grant as well as the stay and everything, just to give them an experience of, enjoying the coding competition as well as the networking. So the last edition was at PSG. We also host national level coding competition that is known as Lady Ada programming competition. Again, it's a 3-round competition where first 2 rounds are held online, and the third round where we invite 10 finalist girls to come for a physical third final round, and we always co-locate it with our ACM India celebrations, so they can also have the opportunity and the benefit of Hyderabad. Then we have the regional celebrations and buddy projects where we want our student chapters to collaborate with each other and do some events. And we are getting very good responses that student chapters are coming together and doing some buddy projects. So some glimpses again, like what kind of projects they have been doing. So, yeah. Oh, okay. So I just a brief little bit of stats. The research says that women in tech industry is 28%. And if we go at this current pace, it will take 132 to come to equality, right? But the scenario is changing. We can see that the percentage of women participation in tech industry is growing. There are various reasons. As you can see that percentage of women in Indian tech industry has grown from 30% in year 13 to 23, it is now 36%. So it is growing at a slow pace, but it is growing. So why I'm saying this? Because this is where ACM can play a role, right? If we be a part of ACM and we take benefit from the events that ACM does, we can always get good opportunities. ARCS is a opportunity for career, right? So what is women in tech, what we can do? Be brave and believe in yourself, network with the industry, and find yourself role models. And this is exactly where ACM events help. It has been the same in my career also. So my main motive to show this was I want all of you to come forward and participate in the events of ACM and ACMW for all the girls and the ladies sitting here. Right. So now our panel. So we have panel discussion today on the topic that is navigating the leadership ladybird strategy and stories. And we have pulled some experts from academia and industry. And I hope we all will definitely benefit from their experiences and the stories that they will share with us. So we have Chitra Babu, Professor, Department of Computer Science and Engineering, SSN College, as the moderator of the panel. I invite her to introduce all other panel members and take the panel discussion forward. Thank you all.
Good afternoon, everyone. I hear something. Good afternoon, everyone. Thank you. Thank you. I welcome all of you to this afternoon ACMIW committee's panel discussion on navigating the leadership labyrinth, strategies and stories. So I would like to call upon all our esteemed panelists after introducing them. First is Dr. Ruth Lennon. She is a lecturer with over 20 years of experience in the Department of Computing at Atlantic Technological University, Donegal, Ireland. She has been a member of ACM for over 20 years and is the global chair of ACMW and member of the DEI committee. I'm not going to read everything here. You can look at her achievements here. And she has worked on projects to support and encourage women in computing and engineering career pathways for as long as she has been involved in computing. Welcome, Ruth. I would like you to take your seat on the dais. Please give her a big hand. And next panelist is Dr. Geeta Manjunath. You heard her in the morning. She was our first keynote speaker. So I'm not going to again read all her bio, but she's the founder and CEO, CTO of Neramai Health Analytics, and with lot of accolades and awards. So I think definitely we will be hearing her valuable insights in this panel. Please come to the stage, Dr. Geeta. Our third panelist is Dr. Noeline Jacob. She's a scientist G and Deputy Director at Advanced Data Processing Research Institute, Department of Space, Secunderabad. She joined ADRIN in the year of 1992, and she has been working in the field of satellite image processing, GIS, data analytics with image, video, audio, and text data. And she has established, developed workable methodologies and led teams for solving problems in variety of civilian strategic domains for MOD, MHA, and she has spearheaded the projects with various departments and ministries. And she has more than 50 research papers published in international journals and symposiums. I would like to welcome Dr. Noeline Jacob and ask her to come to the dais. Our fourth panelist is Dr. Alpana Dubey. She's a principal director at Accenture Labs, Bangalore, where she heads Digital Experiences R&D Group. Her research interests are in the areas of intersection of human-computer interaction, AI, and software engineering. And she is a member of Board of Directors of iHub Divya Sampark, established at IIT Roorkee by the Government of India. And she is also presently ACM India Women's Committee member. And she holds 40 issued patents and 41 peer-reviewed papers in reputed venues. And please give her a big hand. And I would like Alpana to come to the stage and occupy her seat. Introducing, setting the context. So as we was telling that it can be can be research labs, or it could be corporate, or it could be they could be establishing their own startups. So today we are here to talk about leadership. What is leadership? So leadership is about championing for a particular mission which you believe in and inspiring others in that journey. So how can you build the necessary skills, confidence, mindset, and network to take charge of your own future? And how can you hone your identity to steer your career in the direction you desire? And what kind of strategies women should follow to break the glass ceiling? And are the same opportunities available for female professionals as they are for their male counterparts? So this panel will be deliberating and discussing on all these dimensions, and it would be a real, that is, their insights will be helpful to the young women who are going to enter into the workforce to become inspirational leaders. So in the first round, I would like our esteemed panelists to share their journey from this angle, that is, what kind of leadership challenges, that is, what kind of challenges they faced and how they overcome those things, and what kind of traits made them great leaders. So I would like all our panelists to go one by one to narrate their journey. So I'll start with Alpana.
Hello, am I audible?
Yeah. Hello, everyone. First of all, it is my great pleasure to speaking in front of you and all the great ladies. And I hope I present my point of view properly. And I feel honored to be in this panel with all the great personalities here. So yeah, to start with, as you have asked that uh, uh, challenges, I would say challenges are like part of life. We should not call it challenges, and our memories are also no, I mean, once it is over, we don't really feel that challenge as long as it is. If you ask me that, even the pandemic was a big challenge for me, because I was having 1.5 year old baby when the lockdown started, and I had lots of responsibility in terms of working in the office and also keeping the morale of the team high and all those things. So probably I won't talk too much about the challenges, but probably I will talk about in terms of what works and what has worked, probably in my opinion, in my favor or in my career so far. So one of the thing is the relationship and the trust. So I find that trust and relationship has played a major role. Uh, I mean, I have always been fortunate enough to be having the great advocates, great counselors, and even a great help at home in terms of my family members, my husband. And apart from that, the type of trust I have got from my team and the trust which I have nurtured over the year have played a great role. So basically, even the collaborators and all, we have always have a very trusted relationship with them, and I have always made a culture of shared success, open communication. So that was one thing. The second thing which has really worked in terms of, I would say, that I am a great learner. I actually learn a lot. I'm always curious about things which I don't know. And my curiosity ranges from computer science to human factors, psychology, economics. I have recently read interesting books on behavioral economics and neurobiology behind the, I would say, neurobiology behind the behavior, right? So all those things are, you have to learn, and actually you may think that maybe these are not relevant to your career, but it expands your knowledge and it expands your thinking process. And and the third thing which I would say is that clearly communicating the mission and vision of the organization of the team is very important. And it has, in fact, shown to be a most important factor when it comes to the leadership role within an organization. If we are able to communicate to the team members and the team members are able to relate how their work is going to contribute to the mission and vision of the company, I think that's something which every leader who looks to you as a leader actually mm, want that type of characteristic in you and gives you an opportunity further if you demonstrate those. So yeah, I would probably just pause here and pass it on.
Thanks, Alpana. Yeah, I guess that lifelong learning and also that building the trust within your team, all these are, they are coming out as very important points. Now I would like Noveline to narrate her journey in this leadership path.
Good afternoon, everyone. I'm indeed honored and privileged to be part of this panel. My special thanks to Ruthvi, who was in contact with me, though I'm not part of ACM. I come from Indian Space Research Organization, and ISRO is known for its organizational culture. We don't have any gender bias. We are gender neutral. Right from recruitment through all our promotion process, there is no special privilege given to any woman. We have to work shoulder to shoulder with every other man and progress. So in this aspect, there are quite a lot of women who are employed, recruited, more than 30%, totally based on our merit only. But if you see, only less than 2% reach the top. That is mainly because I feel they have not capitalized on the opportunities, equal opportunities provided to them. So I would look at it this way. When I have to lead a team, first I should know what problems I should attempt. I should find the problems. For next 10, 15 years, on which technology I should concentrate, what science missions I should take up, what kind of applications the world will require from me. So these are the visionary role I have to play as a leader to take my team or an organization forward. So in this process, I may encounter several challenges, and my team should be willing to take up the challenges. So I should encourage the team to take up challenges in the sense, even if they fail, they are not going to be penalized. They're not going to be ridiculed if they fail. So when I give that kind of guarantee to them, then kind of bold thinking or free thinking happens. So that is one important aspect which I do with my team. Even out of box thinking, which is having 1 in 10 chance of becoming a success, still it is encouraged. So I always tell them, you attempt. I will recognize you for your attempt. So not making an attempt is often a bigger mistake than making an attempt and failing. So that kind of courage we give to the team who work along. If you ask me how did I reach this position in my career, I would say initially when we are taken up for this post, every individual has to prove their competence. Sorry, am I audible? Yeah. Like we have to take up individual responsibilities. We have to prove our competence as an individual first. Then when they recognize you that you have the potential to do scientific problems, analyze scientific problems, then you will be given a small project team lead. You'll be leading a small project. Then when you're doing good at it, then you'll come as part of the hierarchical structure. You'll be made as a section head, where you will lead multiple projects, then a division head, where you will lead projects in different domains, or diverse domains. So that is how we grow in a ladder from section, from project team lead to section head, division head, group head, and it goes like that. And then you become kind of deputy director. So when you grow higher in hierarchy, you may have to have some techno-managerial role also, not only technical projects. Maybe you have to work on administrative aspects also, like because being a technical organization, you have to do a purchase of technical items, infrastructure building for scientific purpose. So the teams will be held by all scientists only. So that way, we'll have to groom ourselves in the admin roles also, which will not be so comfortable in the beginning. So you'll be trained, you'll be given training during your course. The system has got very good culture of putting you into structured training programs, management training programs, management development programs in the course during your career. So this is how. And what I find is, so initially when I said as an individual, I have to prove I have to have a deep knowledge in whatever I'm working on. Then when I broaden my area, I'll have to increase in breadth as well. So I may not be a good expert in everything, but I should be able to assimilate things in other areas also. And that is how maybe I'll be bothering about nuts and bolts as an individual. Then I have to bother about the major frames and structures when I go higher. So this is how our hierarchy goes. So from depth to breadth we grow, and this is how I am in place.
Okay. Thank you, Nolan. I think that one point which struck me was as a leader, so even if someone in her team is failing, so she will take the responsibility so that they can be, that is, they need not be worried about getting penalized. And that's a very hallmark quality of the leader. When success comes, give that to the team, and failure comes, you take the responsibility.
That is a very culture of ISRO. Even Chairman ISRO, when something fails, he will hold responsibility for the entire nation and take the responsibility of failure on his head. And when its success comes, he will put all the team in the front. That is a nice culture which ISRO has.
Yeah. Next, I would like to hear Geeta's her journey and how she overcame some of the things she said in the morning, but more of her insights. I would like to hear what kind of that.
Sure, thank you. And I think that was a well said statement about who gets the credit of success and who gets the credit of failure. That's right. So as far as I'm concerned, I think I'm probably the oldest on this panel. But it's always been the heart first, right? Like in the sense, what you like to do, sort of keep that in mind. That's how I've always thought about it. And so did my and a bachelor's from India, from Bangalore. And I think first few reasons and methods in which I probably got noticed is because of academic performance, I would say. I went on to top all branches in the state when I did my bachelor's. Then I got my favorite Indian Institute of Science opportunity to do my master's. And even to do the master's in 1981, I know half of you weren't born there, or maybe 90% of you weren't born at that time. Then I think my parents were very, very critical in allowing, or important, crucial in allowing me to study further. Obviously, there's always this pressure of, okay, you're done graduation and go do something else, right? So, so they knew that she was saying, ever learning, I love to learn. I really, so learn one thing every day is my mantra, right? So similar thing. So basically, they saw my passion. Obviously, I did well, and I got a wonderful seat in computer science masters in CSA and ISC, and went for it. And it so happened that I even topped ISC, got a gold medal. So again, I got sort of recognized for that. And I didn't want to do PhD immediately because I started liking doing things which make a difference on the ground, kind of thing, like somewhere somebody can touch the things. So but I didn't want to leave India because I did have a bunch of offers outside, and I decided to stick on and got into the first computer science research center in India called CDAC. Many of you would have heard about that. So that was a wonderful time. We were like, it was more like representing nation. And one thing that made till here at least was, in my BTech, I never used to talk to my male classmate. That's so silly. But yeah, that's how I was. We were very, very conservative. But I had to break all those barriers in my mind. Trust me, girls and ladies here, it's all in your mind. Just you start thinking there is no gender. This is the only thing I tell. I don't know whether any other panelists will agree. Forget your gender. You are no female, nothing. You are an engineer. You are a researcher. That is what you are. And don't get that come in your mind at all. So I have sat in classes of 150 people, single girl in the place. And how the hell can't I talk to my neighbor? I have to. So I have to, nobody said don't talk. It's just crazy. So obviously I broke all that, and then it was wonderful. I worked as one of the members of the first supercomputer from India. But all of these things gave me confidence, I would say. I'm not saying like gold medal is important or getting first or whatever is important, because I never worked towards that, honestly. I always loved reading every line of my textbook. Anyway, my son says, what the hell? But yeah, that's, I used to, every word I had to understand in the textbook. It's crazy. So that's what I used to do. But I think that gave me confidence, saying that, okay, I'm not bad, right? It's okay. I'm at least equal to others and I can go for it. Because I think you mentioned about self-confidence, right? Can I do it? Most of the time you're thinking, why I can't do it? Like, if something is put on, oh, I have this problem, so I don't know English, I don't know this, that's why I can't do. Don't think like that. You see, what is that you have which makes it possible for you to do it? Don't think about why you can't do it. You ask this question, why can't I be the person to take up that task? Ask the other question. Usually, I think females ask and feel less confident about themselves and say, no, that person probably knows me. How do you know that person knows better, more than you, right? So this is just because appearance wise, somebody seems to know, it doesn't mean they have to do better. So having that self-confidence is absolutely important. I didn't get it myself till I got all these sort of ranks and all. I thought I didn't know anything, honestly. And I was not asking. Later, I got confidence in myself. Yes, I can do it, right? Then also in HP, I went on to join as one of the first research members of HP, working out of India, Mera Bharat Mahan. That means my country is great. So I wanted to do that. But I got a wonderful opportunity there to interact with international researchers. I used to go to Palo Alto, work with the international researchers, and it was an opportunity for me to sort of go and present how India can do research. So again, I used to think bigger than myself, and this also probably help you, right? It's not Geeta or your own individual you're representing. You're representing India when you go and present. Here you're presenting all women in computing when you come on stage. If you start thinking you're a representative of a much bigger thing, you just get so much power. You can't even imagine. And when I'm working in Niramai, I'm just thinking about oof, how many crores of women in India, how many millions of women in the world, they are going to benefit. When you look at, it's not about selfish thing at all. It's not about you. Come on, world is such a big place. And in that, Bhubaneswar is a small city. In that, this nicer is a smaller and this room is smaller, right? So we are very, very small. But when you think about what you're representing, what cause you're representing, it really makes you move on. This is something I learned especially when I was at HP. I went there and I have wonderful friends around the world. I learned how they do research. Of course, I used to love publishing papers and getting that 5% improvement in an algorithm and so on and so forth. I really like it even now. But I realized how research internationally is done by connecting this improvement to a real value on the ground. What is becoming faster, cheaper, better in some fashion because of this algorithm, right? So when you try to see till end use level, no, suddenly you realize what exactly is the problem you're solving and what is the direction in which you have to improve it. So looking at research itself differently, and when you start doing it, you start actually behaving like your manager, like their manager in some sense, and you will get noticed and you will get promoted. It's awesome. You're not doing it for that. You're doing it for solving your problem better. So in Bhagavad Gita, they say, karmanye vadikaraste mapaleshu kadachanam, means worry about the work you're doing. Don't worry about the result, right? Work you're doing to the real extent. And I trust me, it has always been, though I didn't know that, I learned that later, but this has been current work you do with 100% now, definitely you will go next. Forget about gender bias, nothing. No, you're a girl, you're a lady, that happens to be one of the parameters of the human being, but you are that intelligent soul sitting here. That is what matters. You have that confidence, you go forward. This is what I would say. Heart, name, remove bias, very much important. Okay, thank you.
Thank you, Geeta, for that wonderful insight. I think her passion comes out while she talks, and that one important point is when you are thinking that you are representing a bigger entity and part of that, then that narrow focus on yourself that disappears, and also while you are focusing on that, automatically your career also makes progress, I guess. So it was a very nice insight from Geeta. Now I will move on to Ruth to narrate her journey on this leadership path and what kind of challenges also, if you could point out.
Thank you.
Yeah.
So my leadership path began a long time ago. I'm not going to start with my birth, but I am going to tell you that I'm from a farming background. And that's all I wanted, was to be a farmer. Sounds odd, doesn't it? I can split a tractor engine, no bother. So why did I end up here? And the simple answer is because somebody saw that I was not challenged enough, not bored. And they said, why not? And I said, no, I can't do it. Can't do it. I'm not going to university. No. I can't do it. So they helped me, and they helped fill in the form. Or rather, should I say, they filled in the form and sent it off for me. But I got there, and I went to college. And I'm delighted to hear that you have confidence and that it's something you can build on, because I haven't got any whatsoever. So I'm going to find out how afterwards. I don't think, for me, that ever went away. I think I'm sitting here looking, I can't believe I'm on the stage with these people. I don't think I will ever gain the confidence I need, but what I can do is take a risk. Because I think risk taking is a large part of what we need to move forward. If we don't try, if we don't put ourselves forward, we might never get there. If I didn't take a risk on going to university, I wouldn't be sitting here today. If I didn't take a risk on doing my master's and paying my babysitter, I might add, more than I was earning for the first year I'm in industry. If I didn't take that risk, I wouldn't be here today. So our background is a part of it, but the challenge, you had asked about the challenges, but the challenge has never been all of these external things. The challenge has always been me. I'm the person who gets in my own way, always. And if it weren't for my network of friends, which I hope is expanding today, if it weren't for my network of friends telling me, just try, what's the worst that can happen? I said that in the committee this morning. What's the worst cannot happen? The worst is a no. How hard is a no going to be? It's painful for an hour. Have a cup of tea, and then you go, yeah, I wasn't really meant for that job. I'll try for this one instead. Have the confidence, but what I will have is more strength to push myself forward and to push other people forward, because my network of friends who are pushing me said, go on the panel, you'd be grand. Or it's a good idea. Or why don't you become the chair of Europe? Or why don't you become the chair of ACMW Global? I'm not from North America. I am not a big person. I'm not currently in any big industry. Yes, but why? Why not? Why not just ask? And I asked, and I got told no. And I was deflated, gutted. And then I asked why. Because you want to know why you're not getting to apply, or why you're not getting to, because you're not from industry. Yes, but why is that relevant? And then I got told, okay, we'll interview you. And here I am. So asking why, you might not have the strong confidence, but ask why and take the risk. And it might just get you that bit further. But my point is more about the human, that our teams, we're here to talk about leadership. And it's all about the fact that there are people in the team. And those people have good days and they have bad days. And they have time they can commit more effort to, and they have times where they can commit less. And being acceptant of who your team is and what they can give you at any point in time, and said, okay, you're under stress, you have a sick child at home, or you have this on. You know what? If you're not 100% there, that's okay. You don't have the time today. That's okay. I know by letting you go today and not do so much, you're probably going to do more for me next week. So I'm going to ask, what can you do? And work with you. And when you tell me, Ruth, you're being too hard on me, or Ruth, I can't do that, I need help with this, they're more willing to say it. And you're going to get the best out of them, and they're going to get the best out of you, because they want to work with you. And it's not for, it's with. So it is all about the human in that team. So be as confident as you can be, but accept that 100% confidence doesn't have to be there. But being willing to try is there, and being a leader, I'm so delighted to see that this is about leadership, not management. Being a leadership is about the people that are involved, not about some group ideology.
Thank you, Ruth. I think, again, she brought out a very important point that sometimes we have to overcome our own internal fears or internal whatever inertia or doubts, self-doubt. I think especially I think at least from literature or by, they tell that women are more susceptible to this imposter syndrome, like thinking even though they accomplish something, but they always self-doubt that whether am I really worthy for this thing or not, that sort of a thing. I don't know how a male would feel, but then more females feel this way. So it's very nice that, so you need to work on your own internal fears, and then if you take that risk, then you can, that is, here she is chair of ACM Global, ACMW Global. So very nice to hear this. So with that, we have come to the end of the first round. Now, what I would like to do is I would like to ask some very specific questions to probe further from each one's that particular context. So, so the thing is, I would like to ask Geeta about that is, when they are going for this kind of startup funding and all. So is it
That is, the situation differs for males and females, or is it the same for both the gender? And my subsequent question is, while you are leading, that is, how can you be assertive but without being branded as arrogant?
Yeah. I mean, arrogance is different. Arrogance is, you know everything, nobody else knows. That's not what I'm saying from confidence. But coming to the sort of the funding and so on and so forth, again, what is in, so essentially focus on the work that you're doing, right? So when you're trying to say this is what it is, the way, again, I thought about it is you're presenting it to the investors. So it's important to try and get into the shoes of the listener, right? Whoever is the other side, maybe for you, what makes sense, we should be talking, and things like that. In a class, what makes sense to the student, so that's normal. Similarly, you to try to understand what does the investor want, right? So when you go to such a forum, understanding what it is, obviously, at the end of the day, they want money, right? So, but it's not so only that. It's also about the reason why they are putting or trying to put money into this, as opposed to, let's say, Paytms of the world, where it's just money. There's no risk as such, in a novel idea which nobody else has done breast cancer screening with this and so on. Means they also want to enable and nurture innovation. So these two angles, So you have to stress the fact that why your idea is the best thing, or it is likely to succeed, not really the best, but likely to succeed in terms of different parameters, the innovativeness, the proof of point, proof of concept you have had so far. And also, they also may definitely doubt the team, irrespective of the gender. First, they will see that the team is good or not. Perception of how much you know about a particular subject is also important. Like, how do you let the audience or the listeners perceive your knowledge is unfortunately important. It's not about how much you know, it's also about how you're able to express it, right? So that's important. And in our case, also we had like, I worked in Xerox and led team. So that kind of helped the team part. And hopefully my gender was not a barrier at all in that particular case. And at the end of the day, trying to make sure that there is a pathway that you can see of success of the startup, whatever is that pathway, you have to give it. So because they are investing, they don't want it to flop. Definitely 1 in 100 flops, or sorry, 10 in 100, only 10 in 100 win. Sorry, I went the other way around. But you try to give all those points in place. So that was it. But yeah, when we went for the second round, there was like, I'm not sure whether as a lady, you'll be able to take on the traditional methods that are very much there in the world. So that those kind of terms I've heard a lot, and I just move on. Fine. I don't need to fight. I don't need to see. That's the other thing. You can't please everyone. You can't be accepted by everyone. Main thing what you can do is don't get affected. That's all. So you have to start becoming rough skin, buffalo skin, jo bhi hai. I know I have cried many times at home. I don't cry, usually cry in front of others. Oh, hurt to hota hai. You will get hurt, but over time you don't get hurt for small things. You get hurt when somebody breaks your, your trust. Those kind of like bigger things. You believe in somebody and they don't believe it. Those things hurt me now. Somebody says something to me, it doesn't hurt me because I know why I'm doing it. And if somebody thinks something, it doesn't matter. It's difficult. It's difficult to get to that stage. Again, like I said, I still have my own low moments. Oh, why did this happen and all of that? But you have to start becoming aware about what to ignore and what to really take. It doesn't mean like she said, no, definitely, if we don't make it, ask feedback. Honestly, you try to correct it. That's when you can move forward. I'm not saying, ignore the feedback anyway, they're not accepted. No, not at all. But I'm saying if it's something about your personal thing, as women, we take it too emotionally. We should take it. We will take it. But try and see if you can reduce that hurt level to some extent. Try to forget as much. And we also try to, oh, I shouldn't have done this. I shouldn't have done this. We go on forever. Forget it. Ho gaya na. It's already broken. Class. Let's move on. I think this aspect is important. So, and several other things, but yeah.
So yeah, that's a very nice observation that whether it is male or female, the technical competence is what matters. That is how confidently you're able to pitch your idea or whatever it is. So if at all you think that there is a because of gender, you will be denied funding opportunities. It's not there. It's a very good to know kind of thing. And also, I think you should not be very hard on yourself for something for a very long time. You have to let it go and then move on. It's a very nice point. Now I will go to Alpana and ask her that is in what way the new entrants, like young professionals who are entering into the workforce, so how are they mentored and what kind of organization culture that is there to help them facilitate a smooth kind of journey. So what are those things? And what leadership qualities are very important in a corporate world that could just help?
So as far as mentorship is concerned, most of the firms, they have very extensive training programs for all the at all the levels, at all the skill levels, based on what kind of career path they are going to choose. There are at least thousands of training programs. There are training programs especially made for women so that they can nurture the leadership roles. In fact, there are gender sensitization programs also made for all the teams so that they are more intentional about in their communication. So I believe that most of the firms are doing all these in quite good amount, and those initiatives are all there. And what I feel is that, having said that, um women have to come forward. In fact, there are lots of promotion also to the women leaders and women for leadership roles. And in fact, Accenture has kind of made a commitment to make it around 50-50%. And right now, about 45% of the women are in the board of directors, and 33% women in executive role, 30% are MD, about 48% women overall, if I look at the mix of Accenture employees. So the commitment is overall there, and there are basically tools and techniques to help them grow further. Mentorship programs are there, internal mentorship programs are there. So yeah, what I feel is not there is that we should not be so much, fearful about coming forward and taking those opportunities. Opportunities are there, but sometimes, as all of us are saying, that we actually undermine, lots of time ladies undermine themselves. So back in 2017-16, we did one study on a freelancing platform on the gender pay gap. So what we did is that we just analyzed in terms of the names of the freelancer, whether it's a male or female name, and uh, the price they quote for the similar type of task. So basically, we actually compared how much price a male freelancer quotes and how much a female freelancer quotes, just to understand whether it's the problem with women to actually quote or undervalue their work than the male counterpart. And there was a difference. So for same type of task, for same type of background for the freelancer, and freelancing marketplace is open, so there is no bias. We can't say that there is any bias actually. But they were quoting less, quite less. So it was about around 35,000 of jobs which were posted on the platform. So what I think is that this is a great time that these things are being recognized, and all of us should come forward and be confident in availing that actually. And that's what I just wanted to add here.
Yeah, thank you. Just an add-on question. So did you ever feel opportunity was not given to you because of gender, or that is you thought that you were worth of that opportunity, but it was denied to you because of gender? Did you come across any such situation?
I don't think that type of thing has ever happened, uh, but I felt that we are not proactive enough to actually talk about our achievement. We are not no, that proactive, and then we think that it's just a simple work once it is done. I mean, that's what I feel, that we have our memories are very little, and we don't remember the greatness and the effort which has gone, and we don't tell the story behind that effort so well, which other parties, I mean, other entities do well. So I think those are the things which we should nurture. So even during the appraisal, when we have to create our own story about any year annual, right? I mean, you may find stark differences between when a female writes about her appraisal versus a male employee writes about his appraisal. So those are the things in which I think we should really learn to present ourselves in the best way possible. And otherwise, I don't think there is any, I would say, biasness at the level of decision against female at any level. I don't find actually that kind of thing.
Good to hear that. So now I'll move to Noveline and ask her a question. Do you think there is less hierarchy in a research lab situation compared to corporates? And what kind of skills are valued in a research lab? And also I would like to tell, that is, I want you to tell, do you have any such kind of experience, like you technically more competent than the male counterparts, but you were not given the due credit to that, it was hijacked by somebody else, such kind of situation?
Yeah, coming to your first question, is there any hierarchy?
Yeah.
Yeah, I would rather say that there is no less hierarchy, there is parallel hierarchy. Like, for example, a new entrant can approach the highest of the organization directly. So there is parallel hierarchy. Though they'll be put into an administrative structure, you'll have somebody to report, and there will be a structure. But still parallel hierarchy is encouraged. The newcomer, the youngster, the youngest of the organization will be called to the boardroom for any technical meetings, and he can raise his voice and give his views like any other senior person. Like, his creative thoughts will be appreciated. And in fact, we like people who say no and contradict the views. No, that is how we can correct the designs if somebody is contradicting, not always saying yes to any senior or something like that. So we appreciate the people who put questions and then correct the systems at the design stage. Even the youngster is encouraged to do that. And they should also be willing to take up responsibilities. Not just an intellectual talent will be sufficient if they're not willing to take up the responsibility. 24/7, they should be available for any of the calls, or any, because ISRO's work are mostly mission oriented. So we need to be responsible enough. Sometimes, no, very ill-structured problems we'll have. We'll not be able to define the problems well. So somebody who has joined newly also should be able to address ill-defined, poorly defined problems, conceive it and give it a shape, kind of thing. So these are the traits, like they should be able to work in multidisciplinary environment, not in one discipline. They should be able to link across domains, areas and work. And they should be a good team player. They can't work in isolation. Will not be able to be successful in any mission. So they should be a good team player as well. So if you are so intelligent and not a responsible person, you will not get a leading role. You have to have a leadership quality, you should take responsibility. And if you don't play well in a team, then you cannot work in isolation. So that is also an important thing. So not only being intellectually well, you should be able to take responsibilities, play well in a team, things like that. What was your
the
third
last question was,
Yeah.
has any due credit to you, your work? Was it hijacked by somebody else?
Oh, I would say never at all. I was given wonderful equal opportunities. Not only me, anybody working in our organization was given equal opportunity. Only thing I would say is women had failed to make use of this opportunity because they shy away from the responsibility when it comes to tools or something like, no, they may not feel comfortable going. They may not be available out of the outside office hours. These are the kind of things which they neglect to come up in the leadership, or take more of the leaves, no, exploit all the childcare leaves which is given just because it is there. Just 1 month leave just before the exams of the students. So I feel such things can be arranged. We can make arrangements or see, there is not much difference between a person, a homemaker spending 10 hours a day with a child, and you will have only 1 or 2 hours, but you can plan yourselves and spend value time. So if one can make arrangements for all these things, and if you're a career woman, definitely there is no way your due credits are hijacked by anyone. You are given due credit. At the same time, you're not given any extra privilege also. You should play among every other men in the domain.
Yes, thank you, Nolan. I'll ask Ruth, so how is it in academic circles, especially in Ireland? I would like to see what kind of difference there between India and Ireland's academia. And also, when a faculty member joins there, what would be their career path? Where would they be progressing towards? To talk about.
So first, I'm delighted to hear that you've never experienced any discrimination. I wish I could say the same, but I can't. I can say I was pinned against a wall and told I was wasting a man's space on a court. And obviously, I wanted to drop out because I was wasting a man's space. And again, if it weren't for certain people trying to convince me otherwise, to stay on, it'll be okay, and I'll be worth it. Otherwise, I wouldn't be in academia. So sometimes the going gets tough, and that's legacy people with legacy ideas, and just accept that they're the odd people. They're not normal. It's not you, it's them entirely. And you're not going to change their mind, so don't waste your breath. Walk away. You have much better things to spend your energy on. You are a better person than them. And just remember that. Always remember that. And it can be hard to remember. But there's a good career there for you in education if you wish to go that route. And the career could be, I want to be an educator. I want to be a lecturer. I don't want to be a researcher. Or I don't want to be a head of department. That's okay. There are different levels for everybody. What do you want to be right now? And whatever that is the right decision for right now. You don't have to be the top of the scale. You don't always have to push yourself. If you need the career break to look after family, just take it easy and give your mind a reset. That's okay. There are paths in research, pure research. There are paths in teaching, and there are paths which combine a bit of both. I actually like the career path that involves a bit of research and a bit of lecturing, because it lets me work with industry. And I teach industry people DevOps, my area of passion. And I spent most of my time working on standards and trying to teach people how to use the standards for their benefit. And that's not a career path you'll ever see written down anywhere. So how do I move into a leadership opportunity in this? Well, if it doesn't exist, you make it. You take on the job, you take on the task, you volunteer to do this thing, and they'll say, yeah, okay, yeah, go do your thing. And then all of a sudden your thing is something you're known for. And then the role ends up having to be advertised as being that position. Or people start looking to you to get the answers because you're the person in that area. If the job doesn't exist, you can make it. It's hard, but you can make the job, whatever that job is. You just have to kind of forge your own path into the area you want, your area of passion. I think you said have a buffalo hide. Yeah, to kind of pick buffalo skin. Sorry, apologies. You know, people are going to laugh at you, really going to give out to you, and I get, oh, Ruth, that woman in computing thing. That's gig. That's what it is. My gig is DevOps. That's what I do. The other thing is something I like to do on the side. It's not what I want to be known for. I want to be known for what I do. I'm just happy to help other people come up with me, and better yet, to pass me out. I keep telling my students, I want them to pass me in a Ferrari waving at me. So smear at me all you like. I want to know that you got there and I had this much of a little help towards it. And that's a good thing. So the career paths are there. They're definitely there. And if the one that you want isn't there, talk to people. Find out how they did it. Reach out and find what's involved, and just volunteer for that job that either nobody wants or didn't exist, and then make it known you did it. Because it's all well and good having this great activity that you're working on, but if nobody knows, then it's hidden work. And in industry, we say no hidden work. If it's hidden work, it's not doing you any good, it's not doing the company any good. At least if you say, this is what I'm doing, however you advertise it, if it's just having a chat with the boss saying, this is what I worked on this week, it doesn't have to be a big Instagram post. I don't know Instagram, but it doesn't have to be an Instagram or a LinkedIn or whatever. Just the right people need to know. So have a cup of coffee, say, go for a cup of coffee. I just want to update you for 5 minutes and tell them what you're doing. And I can't believe you're doing it. You met who? What were you doing? Why? The opportunities are definitely there.
Thank you, Ruth. Yeah, I would like to ask all of you that how can, there are a lot of young women who are going to enter into their professional career. So how can they balance their career and their family and also whatever their passion? So how can they do that in an effective way? Anyone can take it. Yeah, Peter.
Okay, I can do it. Sure. So not that I have a mantra for everything, but definitely what has worked for me is, of course, I have a wonderful, understanding husband who let me follow my passion. That's good. He's also moody. Not every time say, "Ha, Geeta, good." No, sorry. We have all the good fun and fights and so on. But again, it need not be family members or anyone else also. You should know what is making them say that. If there's some of this frustration, maybe they're saying, that intent-wise there is a support that is more than sufficient. So I think family support is definitely important, but it won't be like a constant, always good. Don't expect. We generally female want beige for everything. Why? I mean, what you're doing, and every time everyone is a person, they have their own priorities, right? So that you have to remember. But I've been from a traditional family as well, where I had my mother-in-law, whom had to be taken care of, parents at home, and so on as well. And small babies, or now they're all big. So one thing that I did was, of course, I took a very small break during my, after my daughter and son were born. I kept in, like, whenever there was free time, I kept in touch with the work in some fashion, not like always doing computers, whatever. Some level of keeping in touch will help, because when you go back, you're not fully sort of forgotten everything. Just sort of being in that path would help. Second thing is, you will have priorities. There will be days when the family is the priority. There will be days where office is the priority. That will happen. You have to be clear that this is going to happen. It's not like always work is priority, always home is priority. And you also have to make it known to your people around in the family versus this. And what has helped me is open communication. If, for example, my daughter is sick and I'm not able to do this, daughter is sick, and I mentioned, sorry, I'm trying to do my best, but this is what it is, right? So they know how to manage around you, right? Within the office, for example. Similarly, the other way around, if there is a major deadline, you're working towards your paper deadline, or you're working towards a delivery, my husband knows it. He calls it Grahan, okay, up 12 o'clock, like US deadlines are 12 next day. Many of you may relate to it. So up till 12, he will not talk to me, right? He knows even if we talk, I'm not listening. So this is to happen. After 12, I come out of the room, I'm normal. So if you let them know this is what it is, then they will also be able to accept you as it comes. So this kind of, having this open communication both ways. Not every small thing you need to tell in office, but really major ones. I think that has helped. Let's say if I have to go for a parent-teacher meeting for my daughter, that's going to be in my calendar. Just like meeting with the CEO of another company, it's going to be in the calendar. It's okay. I have this blocked for 2 hours because I'm going to the school to meet, and I'm completely fine with my team member doing the same thing. I tell them, because then they feel comfortable doing the same thing, provided I know that they are kind of, working hard and sincere and so on. I think that's important. I think this kind of a balancing of ensuring, first is ignoring, again, I think that's important, where, not getting hurt if at all, but also prioritizing the right thing at the right time is important. I remember my mother-in-law was very sick. She was in the hospital. I know I had to take care of her. For the whole week, I worked out of hospital. What is that? WFH, work from home, and I work from hospital. I just told this is what I'm going to do. And I actually worked more because she hardly needed me to sort of do everything. And she was sleeping and I was doing. So I was completely in the hospital working. So this, of course, now it's very common, like hybrid and COVID, but at the time it wasn't. Similarly, to my team members also, I give them that comfort. I think it's like leading by example. Look, I have many, near like 70% girls in my office, right? So leading by example, they feel comfortable. And one of the best dependable results have come from female employees. That I have wonderful male team members as well. Definitely, not saying sidelining this, uh, but one thing we have to make sure, and I think you were referring to it, is that, or you were also referring to it, is that if somebody is in the office or made to a position, it is they are as equal or better than the rest, and that's why they're there. It's very important to have your processes clear. You are not having any bias towards because of a lady you're getting in. No, absolutely no, because then the team member is not treated with respect later. So it's very important that if you have made it, it's because of your talent and skill and not because of your gender. Yes, maybe if two people are there and one is a male and female, you may choose this person. That's up to you. But unless they're equal, I don't think, that it's important to have it as a process. It's important to also express it to as a leader, like as you manage people. So it's important to express that also. I'm sure people will agree, but they shouldn't have that feeling
Thank you.
built
Thank
into
you.
the team.
Anybody would like to add?
You have to prioritize. Am I audible? We have to prioritize. Like when I was growing up, studies was my priority. My parents were for it. So when I got married, my husband also come to understand that I'm a career woman. So my career is important. He was supportive. Like when there is important things, he will take up the household jobs, cooking, washing, anything for that matter. Then when I had my son was of course my priority. So I had to prioritize my time, what I am going to give for him. So we divided the job like this. My husband is from art background, so I told you take care of language, social studies. I will take care of maths and science. Then also I'll tell my son, right from the young stage, I made him little independent. I will tell him, see, when you don't understand something, either you have to ask me or your teacher. You don't study anything, you don't understand. So that way, half of my load is there. So he understood that he has to understand and study, and whenever doubts are there, he will come to me. That way, only minimum time I need to spend with him. So for exams also, I'll tell him I may go on tour anytime. Like, so you don't wait for the last minute. You just go through your exercise fully and then be prepared and give me enough. You keep enough time for yourself. Don't come in the last minute. He was a good boy. He understood everything and followed. And he did well in his studies also. Though I spent minimum time, he didn't go for, he went for an ordinary school nearby only because access was very close by. He did all the time well. So whenever it comes to my colleagues, I am a living example. They all know it because we all work in the same organization, no transfers. So they know the full life history, family history. So I had not taken any leave. I go with 0 leave right from the beginning. So I will tell whenever my lady colleagues take leave, no, I'll tell, see, you did not spend 1 month for one exam. Huh? Not take leave. I am myself is a living example. You have seen me working late hours, not taking any leave. So that is how we can lead by example also. Like so, prioritizing and planning is the best way to handle household chores with official duties.
Thank you. Thank you.
So yeah, I agree actually whatever point Geeta and Olina said. One thing I just wanted to add here is that we have limited time, 24 hours. So for few things which someone else can do, I think don't just give it to that. Trade your time with house help. Have that as much as possible. I mean, as long as if you're not able to manage, because work is priority. If that is the priority, then obviously take it and free your time actually for those things. But sometimes if you, let's say, for example, you enjoy cooking, then obviously it's a good change in your, mundane work you might have done, and probably it will really re-energize you with some new ideas. And many times what happens that when you take a break and then you get some more interesting ideas while you are doing something. So uh, one thing is good balance, and don't get stressed out of lot of priorities in mind. Keep few and achieve them. Otherwise, what happens that you really get burnt out. You have 3 lists or 4 lists in for your day to complete, and in the end, you find that you have only finished one task. So be practical of what you can achieve in one single day. Achieve it. Don't get burned out. Have a quality time with family, and trade your time with household helps if at all it's available and possible.
Thank you, Alpana. That's a very valid point. I think should not be try to be a superwoman. So wherever possible, you should delegate and you should not feel guilty about it. I think that's very important. Now I would like each one of them to give some last word, like some key takeaways very quickly, like couple of sentences if people could tell. Yeah, Ruth can go.
Take a risk, accept that you're human. You won't always win, but if you don't try, you'll never know.
Absolutely. I'll say something else which we didn't touch upon about the network part of it. I think we didn't get to that. So it's very, very important to network with people as well, apart from additional things I said. And for that, you have to be bold, right? And especially if it's in a conference or something, you tend to see a lot of male people sitting, and it's okay, go and sit. They may feel awkward, let them feel awkward for some time. And after you start working, start talking to them, then they will also feel comfortable. Yes, na guys here. Awesome, thank you. They're all here. I mean, it's very helpful. I think we should give a big hand to the male people who are sitting here. And they're actually trying to understand what are the problems. I really appreciate that. So it's again, it's all within you. You make your mindset in a way that gender is out. You are the person going forward, just like everyone else. I'm not saying you are God here. No, you are yet another person in the room, but you are not below the table. You are equal. That's all matters. Yeah.
I will go back to the first point. You set your goals high, have a vision. Indeed, you should dream. Dream is something what you don't get while sleep, no? Dream should be something which never lets you sleep. Huh? So you have to dream. And see, we as a human being are endowed with a very wonderful ability to think. I think that's who I am. See, if you see, no, in the nature, human beings are the most defenseless creature. Like I can be bitten by a small insect and I will die. I don't have eyes like eagle to see large distances. So most of the time, human beings are defenseless, but for the quality of thinking. So we should exercise the thinking ability, think, do creative things, to be creative. And never let lose an opportunity. No, don't think that a big opportunity will come at some point of your time. Make use of all small opportunities. Big opportunity may never come. So recognize opportunities and utilize it. And another thing is, you should do hard work. There's no substitute for hard work. Winners always do something more to have a winning edge. Hard work is also important. And we were hearing instances of somewhere you are getting let down. As Madam was also saying, don't keep it for a long time. Have a positive attitude, set it off, and then like every force has got equal and opposite reaction. So the more they pull you down, the more effort you put and push yourself up. That is the best way of coming out of this kind of pulling down, depression, or whatever it is. So nothing can stop you. If something can stop you, it's only you who will stop you. Nothing can let you down. It's only you who can let yourself down. If you think that way, everything, if you take it in a positive way and fight your future, then nothing like that.
Yeah, Alpana.
I would say be bold, take risk. So here I would want to just add that be like a trader in your brain, but be like a mother in your heart. So don't be discouraged about any losses, like how traders, like, I mean, they don't care about daily ups and downs. So don't think about those ups and downs, and be empathetic to the people around you. And that's the quality which anyway all the women have got. And last thing is that love your critique. They give lots of insight. I'm not saying critiques who are just making you turn down, but try to understand what is the message and how you can improve, what went wrong in your approach, what went wrong in your way you articulated your message, and learn from that and be a lifelong learner.
Sure, Pana. And I'll open it up to audience. So we have questions to our panelists. Can ask them. Yeah, audience. Okay.
It's not much of a question, but more of a comment that whatever you spoke about is great career advice, period. It doesn't have to be just for women. So a lot of the things that you said applies equally to men here as well. So thanks for all the great advice that all of you gave.
Anybody else have a question to any of the panelists?
Hello, thank you for the thoughtful discussion. My question stems from the fact that all the people present on the panel are the best people to answer this question. And the question is, what would be your response to people in our field, in the field of computing, who are slightly prejudiced towards women? How should we or any in this room should respond or react when we encounter such a situation?
Am I right? Head up. But I don't. That's me being honest. What do I really do, or what do I really say? Look at the person and think to yourself, are they likely to listen to reason? And if they are, spend the time to find out why they're asking that question or why they're treating you that way, because it's usually down to a misunderstanding. It's not, the bias comes from somewhere. So find out why. Don't say you're wrong. Say, why do you think that way? What makes you think that way? And once you find out, you can fix it. But if they're so strong that you don't think you can convince them otherwise, that they're not open to discussion, then why waste your time? Walk away, save your energy for something else.
Yeah, I think that's a great answer. So try to understand more about what is that prejudice coming from. But initially, in my initial days, what I used to do is I wanted to prove myself right. So I used to spend a lot of overnight and Sundays, Saturdays. When you put up an idea forward, they say this idea won't work. So instead of sharing the idea, I used to implement the prototype, go there and put up the idea. And they say your idea won't work. I said, hey, here is a prototype which works. So I used to do that a lot. And honestly, I was taxing myself a bit, but that it was the early days where people didn't think that anyone of us can do research. But because of that, initially I got accepted, and later I had to do it for like once or twice, and then third time when I said an idea without a prototype, they said, okay, this person is saying something with his name, so you start getting accepted. In case you need to do that, or at least not go full on, but at least go fully prepared. When you're presenting an idea, don't just say hey without your full you think through that idea and then go for it. Especially if you're all in research, it's very easy to get short. You mean what I mean, right? You just say, oh, it won't work, and they'll come up with some negative. You wouldn't have thought about it. So when you're presenting an idea or any point, make sure you've thought through it and then say it. You can also ask it as a question, in which case you don't have to think through it, but you can decide how you want to put it. But this is something I used to do, work a little bit harder. So now, even when I face the investor, I do my homework and then go. I don't know whether it's overdoing, but that is helping me. And of course, what you said, if they are not reasonable, then no point in arguing here.
Any other questions?
That we have to put questions like, no? One can put questions, intelligent questions, and set the other person thinking, no, why such prejudices? One should speak out to be heard, stand up to be counted in any case when such prejudices happen. So that is a strategy.
Do one have a question? Yes. Please, please. Can you give the mic here?
So thank you for the session, ma'am. And I'm an undergrad. I'm just 21, and I'm not into research, like in-depth research yet. But I'm looking forward to doing research. So my question is like, this is not technical actually. You were saying that we just don't pay heed to naysayers who pull us down, who are like, don't do this, don't do this. But how do I know that I should not be listening to them? Because at my stage, like when I'm too young, I kind of need some mentor to tell me what to do and what not to do. But I'm feeling like, is it the right person that I should be trusting? And is it, how do I pick between people who are like good, like really good well wishers and who are not? And as Dr. Ruth was pointing out, like I would like to see people waving at me from Ferrari. Like sometimes, is it always that we spend so much energy on other people as well that sometimes it can be backfiring? I'm just like curious. I might not have much experience as you all do, but just out of curiosity. Thank you.
First, you should believe in yourself. You should be confident in yourself. Then you need not even look for a mentor. How you become confident in yourself? You should acquire enough knowledge about the work on which you're doing, about common sense knowledge. So once you get enough knowledge and train yourself in every area in which you have to get trained, then you become confident. Then once you're confident, you don't even require a mentor to say what you have to do, what you need not have to do, which is right, which is wrong. You yourself will have the competence in yourself to judge which is right, which is wrong. So believe in yourself. That is the point I would like to stress on.
Thank you.
So yeah, I would say same like you have to believe in yourself, but I would differ slightly at the other point that you may not know the field completely. So you really have to understand why the person has said that. And it may be that, okay, he might have not very good intention to criticize you. Sometimes that also happens, but it gives you to really think through the idea or whatever you are trying to present to him, and then it gives an opportunity to talk to other folks that how we can improve it, or if there are certain aspects which requires other types of domain or subject matter expertise, you can really get it from the other people and talk to them. So always try to seek more knowledge from other people, and then make sure that whatever that person was saying was actually wrong. Read the literature and learn from other people, improve. So just see that's an opportunity to improve your idea, your project, or your approach, whatever. So that's the kind of thing which I would actually want to say. Because I can actually remember a lot of moments in my life where critiques have played a major role in improving me. I mean, I can recall some moments in my life in which has which has been the moment in which I really started thinking about, can I not do this? Why I can't do this? And I started working on those and improving on those. So just take that opportunity like that.
Yeah, so I'll try to share my thoughts on the question. But the last bit you said, na, I may not be as knowledgeable as you all, but I thought I'll ask that you cut it off. Okay. It's a wonderful question you asked. It's a wonderful question you asked.
Just I'm
It's
too
not.
young. I just thought I don't have as much experience in the
No,
field as
you
all
have
do.
asked the best question in this room. Okay, that is true. because it is difficult to figure out who is a critic, who is a mentor, who is a well-wisher, who is not. It's absolutely right. My approach is everyone is good. Everyone is a good mentor. Everyone is telling for my good. I start with that positioning. Double click, right? They say something. Oh, can you please tell me? You can say now to him, I'm not as knowledgeable as you. And please, can you tell me more? It's okay, right? When you double click and you know where it lands, that's when you know whether it's a political critic kind of person or not. And during this, you don't have to always sort of try and go and ask there. Can be a dialogue. This is how I feel. That's why I feel different from what you're saying. So you have that dialogue, right? But it's a very good question that you asked, right? It's not always first time you're not clear. First, I mean, some of the parameters are always there. They have done it already. They're already a professor. So obviously they're supposed to know more than you in certain subjects like that, right? They've accomplished. Then they already straight away become mentors, right? But the comment, whether you want to take it as like advice or not, but usually I find, I think she was saying, usually I find that whenever there's a comment there, whether they say it or not, you try to see why they said it, and you can learn from that gap that you have in your thinking. If you try to identify that gap, you can decide whether to close it or not. It's your call. But identify that gap, then it helps either way, even if they're critic or it absolutely helps you. And thanks for that question. You are the first girl who asked this question.
Thank you.
You're very confident.
Yeah, thank you.
Thank you so much.
I think we are running out of time. So I would like to thank all our wonderful panelists for a very engaging discussion. And I also would like to thank you, wonderful audience, for engaging with our panelists and asking very nice questions. Please give a big round of applause to our panelists. I'd like you to.
So, see, actually, I'm sorry, I forgot to introduce you all to Chitra ma'am also. She herself, she's a very senior member at ACM, and she has been heading her institute for 15 long years, leading and with lot of experience, right? So, and my role model, because all my learning at ACM has many time come from her. So thank you, Chitra ma'am, for moderating the panel and all the speakers and the panel members. As a token of appreciation, we from ACM, we actually plant a tree in the name of every speaker. We are in collaborating with 14 tree organization, which plants a tree, and the tree is actually nurtured, and we also get the geographical location and the updates about how the tree is growing. So I will be very happy on behalf of ACM. I would like to present the certificates quoting the trees that have been planted in the name of the speakers here. And for this, I would like to call our ACMW committee members. Hina ma'am, please, to felicitate Chitra ma'am with the certificate. Anjali for felicitating Alpana Dubey. For felicitating Ruth. Manik for felicitating Geeta ma'am. Aparna, for felicitating Noel, ma'am. So I'm very sure that we all have received not only valuable inputs, but even actionable advices that will help us to grow in our career, right, everyone? And yes, as I had quoted in the very starting only, see, previously we used to have ACMW event as a woman-only event, but from this year we have blended it with ARCs and we have a mixed audience because it's not only about women, right? And we can see that we have good feedback also that these things not only apply to women, it also applies to men. And without the support of the other gender, we cannot grow. So I thank all of you to be here. Thank you, everyone. We would like to have a group photo. So if anyone would like to join, please.
It is invitation to all to join for photo. Still, it is not 50-50.
हाँ सर आशुची हाँ हाँ आगे
Hello. Yeah, it's on. So good evening. Thank God, like now you just had coffee or tea after a good lunch. So everybody will, no one will be sleeping for this session. Again, my request to the backseaters, please join on the front seats. It's good to have because we are going to take flipped photo now. So next session, we have by Nutan. Yeah, yeah, yeah. So next session is by Dr. Nutan Lime. She is an associate professor in the computer science department of IT University of Copenhagen, Denmark. Before this, she was associate professor in the Department of Computer Science and Engineering, IIT Bombay, India. She finished her PhD at the Institute of Mathematical Sciences, Chennai, India in 2009. She did a one-year postdoc stint at TIFR Mumbai before joining IIT Bombay in 2010. Her research interests are in theoretical computer science. Specifically, she is interested in algorithms and complexity theory. Her recent research has focused on algebraic complexity theory and lower bounds. She is an associate editor for ACM Transaction on Computation Theory and SIAM Journal of Computing. She received the IRCC IIT Bombay Research Publication Award 2019 and the Best Paper Award for Fox 2021. She contributes to teaching activities at IIT Bombay. She has been on program committee of reputed computer science conferences such as STOCK, Fox, ITCS, and ICALP. She has been part of the Association of Computing Machinery in many different capacities. Presently, she is the ACMW Regional Activities Co-Chair. She was associated with ACM India as the Vice Chair of the ACMW from 2019 to 2021. She was also the Treasurer of Indian Association of Research in Computing Science, India from 2018 to 2020. Nutan is the Outstanding Contribution in Computing Women 2023 awardee. And now I welcome her to talk on the limits of efficient competition and algebraic complexity perspective. Sorry, Nutan, I flipped your slides. Please welcome.
Thank you so much for a generous introduction. And thank you everyone for staying back so late and attending this talk today. Um, efficient computation, namely computation was going on. as a computability. And he put this statement casually in class, and I was stunned by this because I really believed in computation at the time. So algorithms, fast algorithms, and I just felt like we could solve everything. But that wasn't the case, and this statement was very fascinating for me. We have seen such statements in school actually, not about computation, but in mathematics. For example, all of us know that square root 2 is not a rational number, right? So to put it in the words of computability or computation, I could say that my model of computation is representing any number by a ratio of two numbers, A divided by B. So that's my model of computation. Yeah, give me any number, that's the input to the user, from the user. My model of computation is I want to represent that as a fraction, one integer divided by the other. And we all know that this model of computation cannot do that for square root 2, right? So this is another way to show that real numbers are actually different from rational numbers, right? In fact, we've seen this also in school. Suppose I give you a ruler and a compass. And ask you, so these are the operators. Yeah, this is your model of computation. You have only two operations that you can use. You can draw lines or you can use a compass. You bisect an angle just using these two operations. You can use them as many times as you like. Yeah? And of course, we've seen this algorithm for doing it. Yeah? What you do is you draw this compass from the common point, and then you draw two curves, and then you draw a line. That's the bisection. Now, change the problem a little bit. You still have this computational power. You still get a scale and a compass, but now you want to ask, can I trisect an angle? Yeah? Just using these two operators. And it's very fascinating that actually it's known that you cannot do it. Yeah? So it's also one of these statements where there is a set of computation operators that you apply to a class of problems. And in fact, that class of problem is not solvable by it. Yeah? This is saying that there are things beyond computation if you have some restricted operators to start computation with. Yeah? Fair enough. I could also do kind of thought experiment where not only do I bound the operators that you're allowed to use, but I also say that you're allowed to use operators 100 times. And then say that certain functions are not computable if each operators is 100 numbers. Right? So for example, the problem that we're working with is sorting n numbers. We've all done it. And in fact, it's known that if you only use your model of computation among different things, you're allowed to maybe read a number from a list or write a number or something. But the main thing that you pay money for is to compare two numbers. As soon as you have to pay money for comparison, say 1 rupee per comparison that you do, then it's known that you need at least n log n comparisons to sort these n numbers. Some of you may have actually seen a proof for this in your data structures or algorithms course, right? And this is also, in a sense, trying to prove limits for computation. Yeah. So this talk overall is going to be about this dichotomy, or rather, I wouldn't call it dichotomy, two sides of the same coin. Yeah. On the one hand, we want to make advances in designing better algorithms. That's, of course, where we want to make progress. And then there is this sanity check where we ask, is this possible always? So you'll see this keep recurring through this talk. And what I would like to do from here on is to tell you a little bit about my research that aligns with this theme. So everybody okay so far? Thanks. So like the is essential in complexity theory. And in a way, everything that I learned about complexity the first time was from these two people at the Institute of Mathematical Sciences, where I did my PhD. And I started my PhD actually 20 years ago now, 21 years ago. 2003 is when I started it. And on the left, you see V. Arvind. You may have met him at some point, and Meena, who's here, so you can meet her. So they both taught me complexity 1 and complexity 2 when I was a PhD student at IMSC. And in fact, later on, Meena was kind enough to take me as her student when I actually didn't know much about any of this. And so a lot of my learning in the beginning happened from conversations and the lectures that I got from both of them. The point of saying this was that while I knew this overall theme that, oh, if I have a compass and a ruler, I cannot trisect the angle easily, and things like that. These are the statements we often see. But complexity theory, in a way, gives a direction to this way of thinking. And that's the research area that I'm going to talk about now. Yeah. So why should this be attractive? Why should we study limits of computation? Okay, it's one thing that you want to do a sanity check whenever somebody comes up with an algorithm. That's a decent call. Is that all? Actually, no, because there is question that has now become very famous. If you solve this question, you get $1 million. I'm not joking. Yeah, this is one of the $1 million questions for the P versus NP question. Yeah, this is also a question that fits exactly this theme. Can I solve using polynomial number of operations? Yeah, for sorting, we solve n comparisons. Now, I'm not saying comparisons, I'm saying any operations that a computer can perform, and I give it not n log n time, but n to the c for any constant c amount of time. And now I ask, what can a computer do with this much resource, and what it cannot? Yeah, so that's a question that that's a very distinction of the question P versus N. Distinction. There are two specific to people on the Zoom call. Right? So, and it's trying to say that there are these problems that are efficiently verifiable, that those are the NP problems, and then there are problems that are efficiently solvable, and then you're asking, is there a problem that are there provably problems that are efficiently verifiable but not efficiently solvable? Yeah. So, in I will try to forward today. We give a twist to this question where now objects that we try to do are some specific objects. These are polynomials. So what are polynomials? All of us must have seen some polynomials somewhere. For example, this is a polynomial. And for example, is a question that we try to answer. Other related question. So this is a unique one with x, all those are some constants, and then its degree is 2. There is a example of a polynomial. Here, in these two lines are two different of computing the same polynomial. Yeah? One thing is every polynomial one by one. Yeah, this looks computation. On the left, computing on the second line of the slide. Yeah, in which case, actually, end up much fewer of these. So the task is the same, right? We are trying to compute polynomials now. One, three. It has directions on the edges. And I could potentially write this graph down as an adjacency matrix. Yeah, instead of just a graph. Where I put a 1 in an entry in the matrix if there is an edge from the vertex in the row to the vertex in the column. So for example, there is a 1 between in the cell 1, 2, but there is no 1 in the cell numbered 1, 1, and so on. And then, in fact, I could just open this up and make multiple copies of this. Again, some colors are missing. I don't get it. Yeah. Where what I'm trying to do here is between two consecutive set of vertices, there are edges, and these edges are exactly reflecting what were there in the original. Now, if I do, this is like the 8-star algorithm for finding reachability that some of you may have seen. Yeah, but just edges. That's the one I put a very and so one can right the problem of trying to sample reachability in this graph as a question about these polynomials. At first sight, it doesn't look the most natural thing to do. Why don't you just do the star algorithm and be done with it to find this generalization? This there are from vertex to another, for example. Yeah. So there are advantages sometimes to domain of polynomials and ask the same questions that you would have asked, for example, reachability in setting of polynomials. Yeah. Solving, we need to define a model of computation. For trisection or bisection of angles, the operators were compass and ruler. For computing rationals, the operators were representing numbers by ratios of two integers. In this case, people have studied different models of computation. Here is one example where you have just multiplication and addition gates, because that's all polynomials really need for computing. That's all we need to compute a polynomial. A plus gate and a multiply gate used several times in some complicated way. Yeah. So this is called a circuit. It's nothing but it reads the variables. It may read some numbers. I've not written those, but x1 could have been 5 or something like this as well. And then you have multiplication gates, addition gates, and so on. And now I want to ask, what can a circuit of a certain size do? Or I could ask, what can a circuit of a certain depth do? Where depth just stands for the number of cascading layers, and the size stands for the number of operators I use. Yeah, sometimes because cascading is happening in a way that you have a plus gate at the top, multiplication in the middle, and then plus again. Such circuits are also called sum product sum circuits. Very intuitive name. This is a very good shorthand to talk about in the rest of the talk. Yeah. And just throwing in the definition, if this complicated machinery looks like a tree where there were no edges going out from the same vertex twice, then such a computational model is not called a circuit, but instead it's a more special form of circuit called a formula. So we have circuits and we have polynomials. Let's look at a simple example. This example generalizes the example we just saw a couple of slides ago. Now I have n variables. Yeah? And I compute every possible monomial we can with these n variables. So you have a 1, you have a x1, you have a x2, all monomials of degree 1, then you have all monomials of degree 2, then you have all monomials of degree 3, and so on. Yeah, that's what the polynomial on the top is computing. And you can see that it's being computed by a circuit which is plus followed by multiplication, because it's just sum of monomials. And you can see that you require 2 to the n of them because there are so many monomials in this polynomial. But instead, we can do what we did in the previous example. We don't really use 2 to the n operator. What we can do is use order n operator. Yeah? So here I'm giving efficient upper bound. Yeah? Good, fast algorithms. And then later we have a question about this optimum. Yeah? This is a thing that in general, in the field of complexity theory about polynomials, we ask questions like this. How many operations are necessary for computing a specific polynomial? Yeah? And in this case, you could also observe a little bit more about these two polynomials. The top polynomial has a circuit which is of depth 2, and the next one also has a circuit of depth 2, but its top gate is slightly different. So it's not a plus gate at the top. So if you just hypothetically assume that there is a plus gate at the top, then this is a depth 3 circuit. Yeah? And you could ask things like depth of the formula or a circuit or the computational model buy you any more power? Yeah? So the part so to summarize the part about polynomials that I talked for the last 10 minutes or so, it's this one slide. We are asking questions about problems about polynomials, and they are important because they arise in natural settings. The questions we ask are about how many resources a model of computation uses to compute these polynomials. Yeah, and the resources in this case are size, depth, etc. of these models of computation. Again, some shapes are missing on the right-hand side. I even see like a faint edge here, but yeah, for all practical purposes, it doesn't exist, I think. So, some of the results that I have had in the last 10 years or so along the themes of depth of a computation. Yeah, so all of them fit into this. I'll try to bring back the theme about P versus NP before we close this talk. So I told you what the primary area of research does. That is, it studies polynomials and resources required to compute it. Now, for the next, I don't know, 10, 12 minutes or so, I will take a detour to take you through some of the results I've had. And if you want to switch off at this point, fair enough. But then I'll bring you back to the important question of the area, which is this P versus NP question, and relate it to the questions about polynomials. Yeah. Okay. So here is the detour now. Shapes missing. So here is a very, very interesting upper bound result or algorithmic result. It says that give me any polynomial, say it is being computed, say it has n variables, and it has a formula computing it of size s. Then the result tells you that it can actually be shrunk down to depth log S. Yeah, a formula of size S could potentially have depth S or order S, S by 2 or whatever, right? But you can actually potentially, you can always shrink it down to log S, yeah, without blowing up the size too much. It's a very interesting algorithmic result, yeah. And like I said before, as soon as I present an algorithmic result, the question at the back of your mind should be, is this optimal? Yeah, that's what complexity theory asks you to think about. Is this optimal? So are there limits to depth reduction? Yeah. Can you maybe go down to depth even smaller? And what does it mean for a computation to be shrunk down in depth? It means it can be computed in parallel very efficient. Yeah. Something that was probably looking like a very long sequential computation, now you're saying can actually be shrunk down to depth log S. This is a very interesting algorithmic result, as I already tried to emphasize. And now you're asking, can I shrink it down even further? If I can, then it's even better algorithm, right? So indeed, it's not known whether we can or we cannot. Yeah, this question is wide open as the P versus NP question. Actually, for this you don't get $1 million. Yeah, but in some special cases, for example, in the case of multilinear formulas, what is multilinear? It's a polynomial where every variable appears with degree at most 1. Like first is an example of a multilinear formula, the second one is not. And there is actually a thought bubble there that you cannot. And a formula is multilinear. The model of computation is multilinear if each gate computes a multilinear polynomial. So previously, in a couple of decades ago, the following result was proved that you cannot improve the depth reduction to beyond this threshold. Yeah, the number is not so important. It's just saying you cannot do depth reduction to arbitrarily small depths. Yeah, where is the bottleneck? Is that weird function? You can forget about it. Yeah, better than S. Say that in one of our papers for the multilinear case, that indeed, if the formula expect a better algorithm than this. Then ask a fine-grained question about a similar of a similar nature. You can ask, what if I just want to reduce the depth of the formula by 1? I give you a formula, like in the example I showed you, there was a sigma pi sigma formula. Now I ask you, give me a sigma pi formula. Can you do it? And generally, if you want to go depth delta plus 1 to depth delta, there is usually an exponential blow up. What do I mean by that? Let's just look at a simple example. Suppose I gave you the quantity on the first line. Yeah, it has plus operators at the very shallowest level of its computation, and they are combined together by multiplication operation. Yeah, but now I'm asking, can you do the other way around? Yeah, can you have a plus operation at the top and multiplication operators at the bottom? One very simple way to do that is just open up the brackets. That's all I'm trying to say, right? And this will incur exponential blow up. Is this optimal? Yeah, you could always ask a complexity question when you come up with an algorithm. And again, we do not know in the most general case whether this is doable or not. In situations, same as before actually, in the multilinear situations, it is known that quasi-polynomial blow-up is essential. Now, if you don't know what quasi-polynomial means, it's not important. It's showing some sort of a bottleneck to proving better upper bounds. And then in a follow-up work, we were able to show that exponential blow-ups are actually essential. But all of this in this very special multilinear case. Yeah. Then there are many other results about reducing depth of computation. Yeah, we are still on this detour about depth of a computation, like I told you a few minutes ago. So you have a polynomial. So this is a well-known result. You can see that the result to its optimal level is because of all these works from the past. And I'm sorry that I'm not reading out every name right now, but that is just in the interest of time. You can always come and ask me or any other experts what for the references. So what this result says is that if you have a polynomial p of x on n variables of degree d that is being computed by a circuit of size polynomial in n and d, then in fact, it can be computed by a very, very shallow circuit, just plus multiply of this weird size. Yeah, again, the quantity in red is not super important, just tells that n variables and d, then the most obvious upper bound is n to the power d. So this is saying something slightly better, which is n to the power order square root d. Yeah. So it's giving a non-trivial upper bound for a computation which works in depth 4. In fact, the result carries over to depth 3, very beautiful result. And one of the authors for this is with us, Neeraj Kayal. He's famous for many, many beautiful results. And this result says that, in fact, you can go down to depth 3 without blowing it up any further. Yeah. So you can actually depth to spend those many operations. Next, this right? So what are the limits to depth reduction? And there were many results known. In the most general setting, this was the best result known before our work, that you require, again, these exact functions are not so important. What they're trying to say is that we can do something in n to the square root d operations. How many are essential? Are all of them essential? Well, previous results said that at least n cube is essential. Yeah? The functions are far apart if d is very large and close together if d is small. Then, for very special cases, for example, in the homogeneous case, again, a bunch of people contributed to this line of work and obtained the optimal lower bound. That is to say that in homogeneous setting, you cannot improve this. Those many operations are just essential. And then, more recently, we were able to prove this couple of results, which showed this tightness in the most general setting as well. And then there was some, this was a result that got some recognition, right? So that was my detour to through some line of work that I have contributed to, and it's super interesting, obviously. That's why I even talked about it. But bring the story back to where we started. We talked about the P versus NP question, and it is an important question in complexity theory because complexity theory asks questions about limits of computation. So, in the spirit, polynomials, people came up with an equivalent question that talked about efficiency of computing polynomials. Yeah, and that question is now very well known. Called the VP versus VNP question. Again, there are two circles here, two ovals here. The inner oval encompasses the smaller class, believed to be smaller class, VP, and the bigger oval encompasses this class called VN. Yeah, just like the P versus NP, this is VP versus VN. VP is believed to be weaker than VN. So we believe that there exists this polynomial that sits inside the class VNP that's not inside VP. And why is this called VP and VNP? It's because the questions were proposed by Valiant, whose name starts with V. So he didn't name them. Others named this question VP versus VNP. But it's quite an important question now. It was stated more than 4 decades ago by now. Yeah. And just to give you a context of what VP and VNP stand for. So VP is a class of all those polynomials that are computable by polynomial size circuits. So this is not exactly a definition because I'm missing a key point here about these polynomials having polynomial degree, but that's a technicality. For the purpose of this talk, I will not emphasize. On the other hand, what are VNP polynomials? Again, with a little bit of liberty, this is not the exact definition. This is a class of polynomials such that if you give me the name of any monomial from that polynomial, let's say you say it's x1, x2, x3 squared, then using a very small amount of computation, very efficiently, I can tell you whether it appears in the polynomial or not, its coefficient 0. That this class of polynomials is the class Bn. Okay? So it's a very P versus NP. Yeah, because it's a class of problems that are solvable efficiently, and NP are the class of problems that are verifiable efficiently. So it's very similar in spirit. So we want to attack this problem in algebraic complexity, just like everybody wants to attack the P versus NP problem in the general Boolean computational setting. And how far have we come in trying to do this? So again, by the depth reduction results I told you about earlier, something very interesting is known. If you can show that there is a polynomial in this bigger class VNP such that no circuit of that size, yeah, you're looking at a quantity that sort of looks like n to the 0 point something more than half, and that's all it is, right? So if you give me, there should be like a omega there. Yeah, sorry about that. That's a typo. There should be an omega there. So n to the omega of this size for a polynomial, if you can prove such a lower bound, then you will in fact show that VP is not equal to V. Yeah, so proving such a lower bound, and very similar lower bounds we were talking about just a few slides ago. So saying this will solve the VP versus VNP question. Again, a little bit of a bummer that this does not give you $1 million, but that's fine. Yeah. And then where are we? Get a lower bound of 0.5. So if you're somehow able to improve this lower bound from the yellow box, well, the yellow box is not quite visible, but this little thing that appeared to the left of the arrow to the one above, then you would have solved an important question in algebraic complexity. Yeah. So that's where we are right now. So this is also sort of saying that we are at a very interesting juncture, perhaps. One never knows, obviously, but and so there may be exciting things coming up, or there may be approaches for solving VP versus VM. Okay. So that's really technically what I wanted to say here, but I would like to close with some future directions. So for this, I sure again know how to make you see this actually. So I think a little bit is visible. It's like a mountain that I'm trying to visualize here. To the top of it is VP not equal to VNP. And of course, the mountain doesn't quite end there, right? The slides sort of don't give me enough room, but there should be like P versus NP sitting much further up from there, right? So this is not the end either. Suppose that's the goal for now. Suppose VP not equal to VNP is the goal. And in terms of what I have just contributed to, there are many results that one could talk about in this region. But for example, we know something now about these circuits which have constant depth. Yeah, depth 3, 4, 5, whatever constant you pick, I can say something about it. here. So we need to close the gap between these. And one of the two results that I mentioned sort of improved the first one slightly, but in a this beyond multilinear model again. Working in the area, getting excited to work in the area is forming a lower bound. That is, all these small depth circuits that we were talking about can actually all be captured by another model of computation called formulas. Yeah, I told you about it many slides ago. I don't expect you to remember them, but they are weaker versions of circuits. So P versus NP asks you, can you show something that's not computable by any polynomial size circuit? Now I'm asking you, can you at least show that it's not computable by polynomial size formula? Yeah, which is a weaker model. So this would be sort of things lined up forward on the path. And I'm not going to talk about any of the other things, but of course, there are many, many, many interesting things that are going on in complexity theory that I try to keep up with, if not contribute to, but have contributed to in the past, such as structural complexity, space bounded algorithms, Boolean circuit lower bounds, distributed computing, structural algebraic results, and so on. So this is just to say that I just gave you a very thin slice inside complexity theory, and inside that just what I'm focusing on, but there's so much else going on. And yeah, think of this talk as an invitation, at least to the younger crowd, to take up complexity as a future option. Yeah, thank you. There's one mic here. Right, good question. Right. Wow, very good questions. I hope the questions were audible. Yeah. So first question is whether this has any bearing on, so resolving VP versus VNP, does it directly help P versus NP? So what we know is that resolving it will not immediately help, but it is in a way a step towards proving P versus NP. In that, there is a result by Berkey sir from 2000 that says that this problem is philosophically easier than the P versus NP problem. So if you hope to prove P versus NP, kind of you should have been able to prove VP versus P. Of course, it may not go this way. The second question was about distributivity. So I'm assuming that there is a plus gate at the top, then a multiplication gate, then a plus gate. So this, as was rightly pointed out, assumes that there's some level of distributivity that we assume on the underlying algebra. And actually, people have studied models where you don't assume distributivity, you don't assume commutativity, you don't assume associativity, and they have results there. So indeed, yes, people have considered that. I can point you to. There are very few papers in that domain. I mean, in the non-commutative setting, there are many papers again, but in the non-associative and non-distributivity, I think non-distributivity, I don't even recall anything, but yeah, for some other kind of algebras, for non-associativity, for example, there are results. There was a question there as well. Hi, nice to meet you.
That lovely story about what excited Nutan when she was in class in this domain. What do you think we should be doing differently, if anything, to excite the new Nutans who are sitting in class? Yeah.
Yeah, I mean, you are the expert in answering this question as well. I know far too less compared to you about this. I don't know. So personally for me, role models really help. So just being able to see other people do this thing and actually have like a path ahead of them, this helps. But of course, we can't imitate that in a classroom. So for a classroom setting, yeah, I think math can be, you know better than me that math can be taught so much better, right? So yeah, I think there are many ways to improve math teaching. Um, my feeling is that people who are super interested will anyway, find a way. But I think it's for people who may not start out interested and give up because nobody kind of inspired them. So yeah, it's a very difficult question to answer, but yeah, thanks.
Hi, Nutan.
Yeah,
It's
hi.
very difficult to like put things which are very complex in an intuitive way, and you have done that. So thank you for doing that. My question is, what sort of techniques are used to prove these lower bound results? And that's the first question. And another question is that, so in complexity theory, people are looking at this average case analogs of P versus NP.
Yeah.
So are there average case analogs for BP versus BNP as well?
Yeah, very, very interesting questions. Again, so the kind of techniques that are used, I would be using a very broad brush to say this technique or that technique, but there is actually one technique that I can talk about, which is used in many, many of these lower bounds, which is to analyze, essentially, it boils down to the following, what shall I say, proof outline, where you design something called as a measure. Think of it as a weighing scale. You design a weighing scale. This weighing scale is allowed to weigh, so I shouldn't use it like this, like a weighing scale like this, which gives a number. So you put any polynomial on this weighing scale and it spits out a number. That's what a weighing scale is. You design a very clever weighing scale, which does the following, which has the following features, that you take the hard polynomial that you want to show is not easily computable by the smaller model. When you put it on this weighing scale, it gives a humongous number. Yeah. But when you put any polynomial computed by this model of computation, let's say depth 3 formula, when you put it on this weighing scale, it gives a very tiny number. And then this kind of differentiates all the polynomials computed by depth 3 circuits versus the hard polynomial. So if you are alleging that this hard polynomial were indeed computable by the small model, weaker model, then shouldn't it have thrown a high number for at least some of them, right? So this is how one differentiates. So differentiating measure is sort of the clever part of these proofs often, and it relies heavily on linear algebra. So it basically often boils down to computing rank of certain spaces. So that's one, but of course there are many other kind of results. This is again the slice that I'm most familiar with, but there are many other techniques. There was a second question. Average case lower bounds. So not exactly average case lower bounds. So that's a plain and simple answer, but there is like this whole lifting from Boolean setting, proving results in the algebraic setting. So you want to do things like, oh, what does pseudo-randomness mean in the algebraic setting? And then how do you build objects in the algebraic setting that mimic the behavior of philosophically behavior of the objects in the Boolean setting and things like that. So there's a lot of back and forth that people are trying to do. But a specific average case lower bound, I'm not aware of, but is there one? I don't know. I'm not aware. Yeah.
Any question? think there is no question from audience. No. So thank you very much, Nitin, for making complexity talk very simple. Now I invite Ruthvi to present a token of appreciation as a tradition of ACM. ACM will be planting, has done tie-up with the like 14 trees. They are one of the sponsors. So with your name, there will be tree planted near Pune and it will be nurtured and you can track the growth. You will get dashboard on your mobile.
That's very impressive.
Okay, thank you once again. The Zoom meeting, right? Just
That was all from the ACM Annual Summit. And to present the vote of thanks, I would like to call Manik Gupta.
And so not taking much of your time, I'm here to thank ECM India W Committee. I would first of all like to thank all the esteemed panelists who spent their valuable time and provided interesting anecdotes from their own life journeys and shared some interesting insights with the young researchers here. Of course, I would like to thank Nutan, who made all the way from Copenhagen to be here with us and deliver a talk. And of course, as serving as a role model for the researchers here. And finally, we would like to thank our various sponsors and NICER for letting us host this event. And of course, the researchers here, all the young people sitting out here, listening patiently and taking in all the, insights with such great intent. So thanks everyone, and have a good evening. Yeah, thanks.
Okay. Start. Can you hear me? Yeah, okay. So you can get only voice or the video. You decide. उनको कुछ और है Is there internet here? Is there internet here? If I send you a link, can you open it here? Okay, can you do that? Get this out of here.
the Josh? Huh? Full. Wow. How many of you are PhD students? Okay, let's do. So till I think they're figuring out. So they got my slides at least somewhere. So how many of you know ACM India activities? What all does ACM India do? Give me some things that ACM India does. ECR, okay. Huh? Travel grants, okay. What else? Huh? ARCS, okay, good man. What else? Anveshan Setu, okay. What else? What else? PhD clinic, okay. Student chapters, summer schools and winter schools. Women, okay. What is women? Women, what connection to ACM India? ACM I-W, that's not mine. Okay, good. So what my part was, I'm going to talk about it within ACM India, there are like 7, 8 or 10 different verticals that activities happen. One of the vertical is called Research Facilitation Committee, which is what I'm part of. So we thought we will actually talk about RFC, what all activities that we do, why it is relevant to a PhD life. More recently, we have started thinking about PhD roadmap. We're saying that, look, we'll help you in different aspects of PhD life. Thanks to Ian during lunchtime or something, he said, oh, let's just call it as roadmap. So we'll do roadmap type. But the activities, at least in the last 6-7 months, we have been thinking that it's nicely fitting in a way of getting into a PhD and getting out of a PhD. I think Nuthan also talks about how did she get excited about research? So for that, we started doing something called as rocks. How many of you know what is rocks? Not the pattar wala rocks, right? ROCS. It's not the ROCK, right? So we started this. We did initial editions like early last year, 2023 January, something we started. But off late, we've been very, very active in terms of getting all the sort of going different parts of the country and doing talks at different places. Now remote chalega? Yeah, remote. Okay, very nice. Okay. Okay, yeah. So RFC is all about to enable research activities. I think many of you said few words, Anveshan Setu, PhD clinic, all of this falls under the RFC activities. That's the broad scope for RFC. That's ROCS, right? ROCS, Research Opportunities in Computer Science. So the goal is, okay, look, there are how many of you are professors? How many of you are finding it hard to get PhD students? Right, so that's the problem, right? That's the problem we started thinking, okay, now how do you get more students to come and get excited about research? We can't really teach courses to everybody and get them excited, but we said, look, we can get like large campuses, particularly where there is research focus in campus. We'll go there, get 200, 250 plus students, get them to come, spend a day with us, get 5, 6, 7 professors to come and talk about their research, tell them about what all exciting things are going on, and then hopefully they will get excited about something, and then conversations will continue. That's the idea. So first one we started in SRM, that's Venkatesh, I saw him here, right? So Venkatesh, Shweta, we started there. Very modest starting, lots of lessons we learned in the first 2-3 editions that how to plan it. Then we went to IIT Palakkad. It was a huge success. We had like 300 plus people. You can see that picture, right? 300 plus students come, and we got very excited about it. So we said, okay, we'll try more editions of this. After that, we've been very, very spending a lot of time on this. Particularly in 2024, we have planned the entire calendar, right? So we want to do it once every month, 4th Saturday. We want to do a rocks. That's the plan. So the one at the bottom right is TKM Kerala. January month is the IIT Madras. Anybody from IIT Madras? Okay. February is IIT Bombay. Anybody IIT Bombay? Yeah. March is NIT Trichy. April is IIT Hyderabad, right? We're still looking for, we have few options for May, June and July. I'm talking to some people for later this year. So once a month, 200 people. So hopefully in a year, we should touch 2,500 or 3,000 students, undergrad students, to tell them that what research. Yeah, yeah. No, we can do. Meaning we had one student took a flight from Bombay to attend the IIT Bombay, but we can't pay the tickets. You come from anywhere you want, we will support your food and activity, speaker activity. Oh, Venkatesh is back here. Sorry, I was just referring to you a few minutes back, right? So the students can come from anywhere, but the hope is that it will be more of local, so that the local professors have a connect with it, saying that, look, come join. Very interestingly, IIT Hyderabad, when we were talking, they said that, look, our admissions is coming next week. We were proposing a date, and they said that, can we arrange it in a way by which students get excited about us and probably even apply? So you can do all that. Meaning the fourth Saturday is only for continuity and from some planning purposes. Okay, that's IIT Bombay. Oh, so for people who are interested, it's also meaning you can also tell us that you are interested in organizing. And so that's the link that is there. If you just search for Rocks now in ACM India, you're recording it? You're recording it? Oh, okay. Why? Oh, okay. But did you get my consent for recording? Nice. But that was for pictures, not for audio. So audio or video, I should have been more careful. Okay. Okay. That's okay. Right? So if you just search for Research Rocks in ACM India now, you should get to this page. There's a small form which you fill saying, look, we are so-and-so institute, we want to do this. These are the potential speakers that we are interested in, all that. It should work, right? So some of us will look at it and we'll take a look. I'll come back to you for taking it. So the next one is PhD. So now 250 students or thousands of students in a year, we tell them that, look, get into PhD, do research, right? They start PhD, I mean, they want some help after that. I'm sure PhD students, all PhD students in the room will agree that there's a lot of, how many of you are signed up for PhD comics? How many of you know what PhD comics? Oh, please look up here. For PhD students, if you're not signed up for PhD comics, please sign up. There's a nice graph in PhD comics where it shows how your enthusiasm level or happiness factor will be. Usually most of the time below the zero line or something, right? So there is lots of places where you need inputs for. That's what PhD clinic idea is. Can we get actually students who are doing PhD to interact with researchers, faculty who are in your domain and get some inputs from on your research. This is not a one-time thing. You can actually do it multiple times in a year. We generally suggest taking some time between two interactions. So wherever I'm referring, if the people involved in the committee are here, please raise your hand. Where's Mainak? Mainak and Niharika are the people who are actually working on helping this connect to be made with the students and mentors. The mentors list is growing. We get actually requests now saying that, can I get added to the mentors list and interact with the students, all that. So it's actually very, very satisfying to see faculty and researchers are also interested in helping. So that's the PhD clinic. Any guess when these pictures were taken? How many of you in the room, if you're there, can you stand up if you're in the picture? Let's give them a round of applause here. Both mentors and students. Mentors also, please get up. Mentors are also here, no? Right? So thank you for coming. Thank you for actually spending time for mentors. Thank you. Sit down, thank you. And that's the activity that we only recently started doing it in person. Until now, PhD clinic was all online. Mainak would say that, oh, if you ask for this mentor, do a Zoom call, meet call, talk to each other, and then it goes on. But more recently, since everything is becoming offline now, we said we'll actually do offline in conferences. So multiple COTS-COMATs. I'll actually show you some statistics about COTS-COMAT. The PhD clinic at COTS-COMAT this year was about 2,500 minutes interactions between mentors and students, right? It's about 60 sessions. So here also we'll have probably 40 to 50 sessions, 30 plus PhD students, 10 plus mentors. Today also there was a mentor-student interaction which went on for 55 minutes or 1 hour. They start and then they just go on. I think that's fantastic to see. Right, mentor and student, they both are not connected otherwise. ACM India platform is connecting them and they're spending some time on their work. The reason why I asked to post on social media is this, because I think ACM India needs a lot of these kind of feedback, right? In terms of publicly also talking about how it's helping. Here are some examples from COTSCOMAD where students posted about specifically the mentors. Some of the things that I would have highlighted, talking about Manas and Ashtore, somewhere they talk about Partha, right? So this one is talking about Vineet and Jana. All these are mentors. I mean, I'm sure if you're in computer vision, I'm sure if you're in databases, Jayant was actually a mentor also in COTSCOMAD. You would read their papers otherwise. Similarly, Icon Fire also this year, we had PhD clinic. So now, rocks, start your PhD, have problems, have questions, talk to people offline. Offline is harder only when you attend conferences, but online more frequent. Now there is also a next step you can take. That look, I want to actually spend some time with the professor. I want to spend some time with the faculty. That's what Anveshan Setu is. ROGS, PhD clinic, and Anveshan Setu is basically an internship, which ACM India will fund. And there are about 50 mentors right now this year. These are mentors and student pictures in the past. Some of the outcomes from these activities are multiple A-star papers that have come out, research proposals. I know few faculty and faculty, student, and students advisor have written research proposals and gotten funding for it, where they started talking only in the PhD clinic or Anveshan Setu platform. PhD fellowship, there's actually a Microsoft research fellow student who got connected to a mentor through PhD clinic and Anveshan Setu, wrote a proposal. Now he's actually a Microsoft fellow where he's co-advised by his own advisor in the institute and the mentor from ACM India's platform. Fantastic connections that we are making. And co-advisors. Only today morning, one of you actually told me that thank you for the PhD clinic and Anveshan Setu. I went and visited the professor. My institute agreed to have the professor as co-advisor. Now this faculty is also a co-advisor for the students, which is also nice to see at some point. These are some pictures. This year, anybody here who is an Anveshan Setu fellow, or how many of you have applied for it? Very nice. Right. So we have this year's currently, where is Sogata? Yeah, Sogata and Rishabh are the two faculty who are actually helping with going through the applications and figuring out, talking to the mentors, alignment for mentors and students doing all. So that is Anveshan Setu. Once again, let's do Anveshan Setu two more things. There are other faculty who are here, Anveshan Setu mentors. Can you stand? I know Ayan is here. Anirban is here. Who else is Professor Radhika is here. Yeah. Anybody else? Okay, thank you. Thanks again. I think these mentors make these programs enriching experience. So there are multiple emails that we get from students after this experience that look, this is very, very useful. I mean, our interest is also that the student should get, for example, one of the students went, so the funding opportunity that ACM has is only X amount. We are at least suggesting that it should not be less than 4 weeks. But there are actually students who have done 8 weeks, 12 weeks. Your relative lives in Madras, you go do an Anveshan Setu with Ayan. Ayan says, come and sit in my lab. I don't really care how long you spend. With the money that ACM India is giving, you can spend like 3 months with them. Nobody's stopping you. There are students who have actually done it. There's actually 2-3 students who have done much, much longer than what we actually thought that they would. So that's Anveshan Setu. Now that you're doing started PhD, some PhD clinic, Anveshan Setu, all that happens, you need to start doing networking, right? Networking is another important aspect of PhD life also. So that's why these events, not just networking, I think technically also talks, listen to some inspiring people, all of that is what it talks about. So therefore we get you here. Two other things that happen so for PhD students, how many of you are 2 or more years into PhD? Oh, very nice. What are the most critical problems right now in front of your life, other than getting married? What else? बताओ यार, how many of you think that PhD में problem ही नहीं है? Problem ही नहीं है. A changing of supervisor. Okay, what else? What else? Huh? Getting a journal, right? Getting a paper accepted. Let's just put it slightly different. Getting a paper accepted. Hard, right? I mean, getting a paper accepted in a good place is hard. That's the goal. What else? How do you get a good paper accepted? What are the skills you need? Huh? Writing skills. Okay, what else? Finding a problem, right? Finding a problem. That's what PhD workshops are about. Which is that, look, started your PhD, you did your coursework, you finished all that. Now you're finding it hard to find a problem, not able to write properly. You write something, paper is getting rejected. Reviews are coming, but you're not able to actually make the reviewers agree that this is an important problem, interesting problem. That's what PhD workshop is. Take one problem. Take one problem. This problem is, let's take, write a good research paper. It's a one-day workshop where experts will talk about how to, meaning experts in terms of who have done this before, who can come and give you, share experiences. Not just about just as experiences. There have been workshops, I know that this is not the one. There was one which was done only on LaTeX. Just tricks and tips about how to use LaTeX, which is one skill that we pick, and the PhD workshops are done around that skill. Reading papers, I think once there was the PhD workshop on just doing literature review. Okay, the next one, arts, and this I'll connect. The order could have been arts plus PhD meetup also. Is that, look, I think it's not about just coming and listening to people, right? It's also about both of you. How many of you, raise your hand if you know at least one more student, PhD student in the room and you know their research work? Raise your hand if you know two of the research. Raise your hand if you know somebody's research work outside your lab, outside your institute. Lesser and lesser, right? That's because I think you go to conferences, you speak about this. I mean, there's less opportunities about getting into detail. I'm sure you know, what are you working on? I'm working on social network analysis. And then let's go for lunch. Right? So there has to be a lot more things that can happen. That's what this PhD meetup is, which is that students present. So these are all students who are presenting of their work. Students are only listening. There is no faculty. There's faculty only to make sure that it's more like a sanity thing. Okay, they're not sitting and watching a movie inside the room. We gave them a room. They're all enjoying a movie. That's all the faculty's job is. So this is about PhD student presenting, PhD students talking about their life. Again, few hours. This one was done at IIT Madras. We just realized that Ayan is also in this picture. Ayan is actually in multiple pictures of this deck, right? So that's Ayan in IIT Madras when once we did, and again, PhD students. We also get some PhD students who are in the final stages of PhD and talking about the research in very, very detail. In this case, the one in the left bottom on the right picture, she was the IIT Madras PhD. She was fairly in a senior state of PhD. We just got her to tell, how did she go about approaching the PhD problem, right, for people to help. More recently, this is the request that has come from many people to us saying, look, how many of you are doing part-time PhD? The part-time PhD is also a large number. Even though it may not be a large number here, there's a large number of students in the country who are actually registered for part-time PhD. The challenges for them are slightly different from challenges for a full-time PhD. So we ended up actually doing an AMA for this one. Okay, so we did all that. How many of you apply? How many of you have gotten a paper accepted, applied for a travel grant and did not get the travel? Not just in ACM. Did not go to a conference because there was trouble actually getting money for the travel. Many of you, probably some of you are just in the early stages of PhD, right? That's a travel grant is one. This particular grant that we created recently is where Manas is here. Yeah, so Manas, Karthik, Hemangi, and Kriti. They are the people who help with this effort called Research Facilitation Grant, RFG grant, which is, it attacks three specific problems, which is if you get an invite from a invite-only workshop, which is hard to get funding for because you don't have a paper, you cannot justify that why you're going. Second, if you have a open access journal and they're asking you for registration, whatever it costs. Third one, you have an extra couple of papers in a journal and you want to pay and it's actually costing you a bomb, so you can't pay for it. These are three things that, at least over a period of time, senior faculty have identified that it's hard to get funding for this. So we've created this grant only attacking the problem of these three things. Again, invite-only workshop, open access, and extra pages. That, yeah. It depends on the venue. Equality, I don't know what's the. So why should it be a problem? I think Manas and his team will decide what to fund. But if it's high quality, it's high quality, no? I think there's no. Oh, okay. Would ACM pay for IEEE? Why not? It's a scientific thing that you're funding, no? Oh, IEEE is against us, so let's not fund them. That's not the goal, right? Meaning, I'm science ke liye, madam. Right? So, okay, good, nice. So that's RFG. Sorry, you had something. Oh yeah. That came in a couple of places also. For any of the things that I said, you don't have to be an ACM. How many of your ACM members? Okay, but there is one condition. For you to get dinner today, you have to be an ACM member. Without that, we are not going to give you dinner, right? So you don't have to be an ACM member for any of the activities that I mentioned. Please, yeah, thanks Manas for highlighting that. So that's the, right? Sometimes there is also to say, oh, we don't want to apply to this because in ACM, they need membership, nothing. You can attend a ROCS, you can attend a PhD clinic, you come to arts, it's all possible. Okay. So now, so we did all this journey, right, in PhD. Start kara, problems, help liya, network kara, funding liya, travel kara, all that happened. Finally, abhi job chahiye. How many of you are in that stage? Right, PhD khatam ho rahi hai. I'm in the final stages of PhD. I want to find a job. Meaning, of course, your network, your everything that you used before can help. But can we generate actually opportunities for PhD students to find a job, which is very recently we started in ARCS this time also you would see, that's why I took the screenshot of ARCS webpage to put it here. Plaksha University is going to be here. There are going to be people from industry here. How many of you are from industry? Industry people, please talk to them, PhD students. Even though this is, you can go talk is very easy, we can actually set up specific interactions also. We've been talking internally also to say that, look, we can actually get the Plaksha to give, I think there was also discussion about Plaksha to give a few minutes of session, pitch their institute. Institutes who want to recruit good PhD students should get a stage time, let them present why they are the best and get the best students to apply to them. Right? So that's the idea. So starting from rocks, come to find a job. ACM India is there. This morning, okay. I looked at the schedule, I couldn't find, okay, so, sure, very nice. So Venkatesh is saying, how many of you attended these? Sitara, Flame on, exactly, that's the idea. Okay, thank you. Okay, so that's the entire thing. But in addition to this RFC, which is I only walk you through the PhD life of where RFC is coming into play. There's a couple of activities that we do beyond that. Somebody mentioned earlier about just the travel grant, which is called, you have a paper in a high quality conference you want to attend, you're not getting funding, you can apply to this ACM IARTS travel grant, which is for a paper. RFG is not for a paper accepted in a conference. Right? So that's the difference there. And all the activities that are mentioned in slide has funding, which we can generously give for many students. So please apply, please try and figure out whether you can get it. The other one that we do, RFC does is Shelly and Jibby are the faculty who do, they're not here. They actually do the approvals for the workshop. Right? So a new workshop wants a support for travel grant for the student or any support, even the approval for that workshop itself, whether it should be called an ACM workshop on so and so. Those approvals also go through RFC. Those are the two other activities other than PhD students' life that we have. I'm going to ask you to give a big round of applause for all of them. So even though I spoke about all of this, I think it's a big list of 18 to 19 faculty who, including industry, for example, Niharika and Siddharth were here. They were PhD clinic mentors. They actually help, Niharika helps with Minex, the PhD clinic. Siddharth is actually helping with the PhD meetup. It is not just only the faculty, there are also industry researchers who are helping us. There, calendar invite is there once a month. So we plan to meet. Every activity has its own cycle. For example, RFG has Karthik, Manas, and Kruti look at applications once a month, do some filtering of the applications, then we discuss what to provide. Already posted one social media post about from morning. Dinner, keep in mind, वापस जाना है, reimbursement चाहिए, right? So you should keep that in mind. No, please tag ACM India. I think from morning, I mean, we've been talking to, sending messages to ACM India team also, that if anybody tags ACM India, they will like it, they will share it, particularly if you talk about arts. I think your content also is very important for us to generate and so they promote, right? Please tag ACM India, even, ACMW India, right? So please tag ACMW India also, right? If you don't know the handles, go to my post last night, you will get all the handles. Okay? So the recording is also here, which will also go on our YouTube channel. Please spread the word about all these activities. Thank you. That's all I had. If you have any questions, I'm happy. Any questions, any concerns about PhD Live? Here for the event, I think for us, for example, in this case, I talk to people offline, some signals come. Unless the student or the faculty comes back to us, there's no way to even try. These ones are very evident, and the authors, the students and the advisors were kind enough to come back to us. We don't even. Whereas in the travel grant, it's very easy. Just say that, look, I think we say that. Day after tomorrow evening, we have participants. Ideas have come only like in the last week. Migrations have been going, particularly in RFC. Many of these ideas, people tell us, optimize.
Now, the poster session from now to till 7 o'clock. So please request everyone to head out and spend some time at the posters. 7 o'clock, we have the sponsor session here, and 7:30, we have the dinner. Thank you.
come closer and say.
What we are planning.
more people at the posters having good discussions. So I will wait for a couple of. Okay, is this better? Am I audible now? Okay, welcome back, folks. While people join, I can get started. I would like this to be very interactive. Please stop me anytime if you have any questions. I'm going to, as I was saying in the afternoon, Microsoft is a big umbrella of of technology that spans almost all branches of computer science. So no matter which area of computer science you are interested in, you will find very likely that you will find something happening at Microsoft that aligns with your interests. But given my background from having been from database systems, I'm going to take this as an example to showcase what kind of challenges we work on and what sort of career, problem-solving opportunities and interesting challenges that are out there waiting for smart people like you all to come and solve. So I'll kind of go over some of those examples. And as I said, please stop me. So briefly about myself, I'm originally from Bangalore. After my undergrad, I spent 5 years in the industry. Actually, I had a very sort of a different twist. So after my undergrad, I worked as a software developer for 5 years. And after that, the bug hit me that I wanted to go back to school. So but I didn't want to go out of the country at the time. So I focused only on a couple of universities in India, ended up at IIT Bombay, did a PhD in computer science, focused on databases. Yeah, I had a wonderful 5 years at IIT. Since then, I have been at Microsoft. So after finishing my PhD in 2014, I've been at Microsoft. And Microsoft career itself is, although it's now I'm completing 10 years, it's spread between in different groups. So I joined Microsoft in the US as part of this lab called the Jim Gray Systems Lab as a researcher, and spent about 5 years there. Then moved back to India for personal reasons and joined MSR, Microsoft Research India. And in the last three and a half, almost 4 years now, I have tilted towards a little bit on the product side, working as I've built a R&D center for cloud database systems within Microsoft. So that's my current role. About the team that I've built. So what we have built is a database systems center of excellence, as I call it, which works on all aspects of cloud data platforms. You were seeing, I don't know how many of you saw the video that was being played in before this talk. It's actually part of the same group that I'm part of. And we have a strong development team, like an R&D team, which works on both research as well as development in the database space. So with that, I'll jump into the topic. Please stop me if you have any questions, as I said. So I would characterize database systems as an area which is mature yet vibrant. and you will see why I say that. I'm going to talk about what kind of opportunities we have in this spectrum. Again, I'll touch upon different branches of computer science under the umbrella of databases to hopefully motivate you to consider those paths post your PhD. What we always strive for as researchers is that we would like our ideas to actually have an impact on the world, on people, right? And that's why I say, in databases, it's everywhere. So any research you do, anything you do to advance the state of the art in databases, you are impacting everybody, every human being practically, because directly or indirectly, we all interact with databases all the time. Your phone, almost every app on your phone is backed by a database. Every website you visit is backed by a database, right? Every financial transaction you do is making an entry in the database. So I've mentioned a few domains, but as I said, it's one of the most widely used pieces of software in the world. So any innovation in this space, immediately it's huge impact, right? It touches every human being. And the markets are just a symbol of that, a small indication. It's a multi-billion, hundreds of billions of dollars of the addressable market, right? So that's the opportunity for having big impact in the world. Now, the next thing I want to mention is I was saying we would like our research to have an impact on people. The second is we also want to do something new and contribute some new solutions to problems. And that's where I say that it's in databases are a mine of gold mine of problems. There's an abundance of complex technical problems. There's a great opportunity to learn. So to that end, I want to do a small quiz with you all. You all know about Turing Award, right? How many of you don't know what is a Turing Award? Everyone knows? What is that? What is Turing Award? Can anyone tell me? Yeah, absolutely. Yeah, it's the Nobel Prize in computing, right? That's the now. I just want to take an example. I'll ask you a question. Now that you answered that, we'll ask the next question in the style of KBC, right? How many Turing Awards do you think have been awarded in history, in Turing Awards history, for contributions made to database systems? Any guesses? or before, or I can show the options. Go on. 0. Okay. 2. 5. Okay. I can see that everyone is guessing, which is fine. Yeah, the correct answer is 4. Who said 4? Did anyone say 4? You? You there? Okay. So I'm not going to leave you. There's another question. If you guessed, I'll catch you, right? So, okay, who can you start giving me some guesses? I'm guessing you all have done some undergrad course in databases. Learned something about databases, SQL and stuff, I'm sure, whether you liked it or not. Okay, I'll start. So the first is 1973, Charles Bachman. If you haven't heard about these people, these are great luminaries of computer science. You should go read about them. I strongly encourage you. Yeah, 1973. This one, I'm guessing many more should know. Cord, who was the inventor of the relational model, which is sort of the mainstream databases are all built on top of the relational model, right? So Edgar Cord, 1981. And then third is Jim Gray. Again, I mentioned that I was part of the Jim Gray lab at Microsoft. Jim Gray was at Microsoft. He was a technical fellow at Microsoft while he was a Turing Award winner. Like I was saying earlier, there are many Turing Award winners who work at Microsoft, and Jim Gray was one of them. Unfortunately, he's no more. But he got a Turing Award for inventing the concept of transactions, right? The formalization of the notion of transactions and consistency, which we depend on for everything today. Every time you spend your money, every time you book a ticket, you need to have that notion of transaction atomicity and all that. So that comes from, we owe that to Jim Gray. And then the more recent is Michael Stonebreaker for his contributions to Postgres and Ingress. So I'm just showing this to highlight that database research has contributed to across the decades, right? This is touching multiple decades. And in fact, I would add a fifth one, which is Jeffrey Ullman, who got the award recently. Although the main citation of his award was about his contributions to compilers, he was a prolific database researcher. He has written books and he has written some seminal papers in databases. He was a database researcher. Anyway, so that would make it actually 5. Whoever said 5 can also say that they're right? But the moral of the story is we are standing on the shoulders of giants. Whatever innovation we do, it's building on top of the work that these great people have done, and we have to understand what they did, and not only that, we have to take it forward, right? So that's the opportunity that I feel very, very happy working in this area myself. Okay, so this is one thing I hear from many people. Oh, databases, it's all solved. You know, people have figured it out. We are using it. What's left to be done? It's over. Now it's all about AI. Let's go solve problems using AI. Databases are old and it's over, right? This is a common perception that I do hear from some people. So I want to ask that, answer that question, or at least give my take. So again, going back to Jim Gray, he put up a challenge in his Turing Award talk, right? And he got the Turing Award. He gave a speech where he made this challenge. Again, this is available online. You should go read this. It's really interesting paper by Jim Gray, right? So he put up this challenge more than 20 years ago, that can we build systems that are used by millions of people yet managed by a single part-time person? His choice of the word, right? But so the question is, are we there yet? Right? I would say yes and no. We have built systems that are used by millions of people. Cloud is the example. I'll talk about that. Right? Cloud is one such system. But we are far from managing it with a single person. I mean, we are yet to achieve that level of autonomy or autonomous operation of such a large scale distributed system. So just an example to say how vibrant the area is still, how many unsolved problems exist, right? There's, as I say, there is a disruption happening in databases, mainly due to these three factors. The cloud has been one of the major big disruptors to databases. It is making us rethink how we design and build databases, how we fundamentally think about databases in the first place is being questioned, and we are actually questioning the fundamental principles because of the disruption that the cloud is bringing. I'll show some of that. And there is also the scale and complexity of data never reduces. It only keeps growing. The kind of, yeah, I just had a few more things to call out. The data governance is another big factor that cannot be just bolted on to databases. You need to fundamentally think about how you can design databases from the ground up, which are compliant and can protect your data the way we would like it to. And yeah, as I said, scale. So all these factors are pulling databases apart in some sense, or forcing us. There's a lot of innovation and disruption happening, and which has given rise to a vibrant ecosystem of startups, as well as big players like Microsoft, Amazon, Google, and so on, right? So this is just a example. I know it's not very clear, but it shows the market share ranks in the database system space. What I want to highlight is this sort of a churn that you see. So this is like these are companies, right? And it shows who was having the highest market share. It's not to scale, but who was at the top. This is Oracle, IBM, and Microsoft, SAP, right? This was 2011. And as time passed and it came to 2021, how the market share has changed over time, right? So you can see that Microsoft has notched up. Oracle has gone down here. Amazon, AWS has come up from nowhere. It wasn't even existent in 2011. Now it is that second, right? Google has, Alibaba is there. Google Cloud has come up to become the fourth, right? So you can see how there are ups and downs that are happening. So many companies are coming up and going away and trying to disrupt the space. Right? Just I wanted to give you a glimpse of how vibrant the ecosystem is of innovation. So I'll skip through this a bit. What exactly is changing because of the cloud? That before it used to be more of customers had to buy their own hardware, they had to hire DBAs, etc. But now it's like one click, you provision a database and you're done. Creating that experience has been a big, and that's the main thing that has changed for Microsoft now. For example, we as a database provider are no longer responsible to ship software. We're not going to sell software to you, but we are responsible to have an entire database service up and running, available 24/7, reliable, elastic, and all those distributed systems guarantees that you would want. We suddenly become responsible for that for millions of databases, right? Azure hosts millions of databases, and we are now, these are the new challenges that we have to address. And on commodity hardware can fail, power outages can happen, and networks can fail. Despite all that, how can you build that sort of a reliable system with guarantees? So that's sort of the way that the cloud is disrupting. Any questions so far? I'll take a pause. Either I'm putting you to sleep, or or this is super interesting. You all understood everything. One of the two. I hope it's the latter. So feel free to bring up your thoughts if you disagree with me or agree with me. Okay, so I'm going to take a detour slightly and talk about how what journey Microsoft has been through in this space, and use this to highlight how research contributions have come out of this disruption from a Microsoft standpoint. Hopefully, again, to motivate you all, right? So you all might have heard of Microsoft SQL Server. It's a well-known database product that Microsoft has been selling as a software for decades. But making it into a cloud service, it's not like, okay, take a database, put it in a VM, put it in the cloud and say that now it's a cloud database. It's not as simple. So that has, it has made us rethink, like I said, how databases are built. And that has led to a lot of research opportunities. I'll highlight the publications that have come out. And also there's a lot of collaboration with academia. I will highlight some of that also. I myself, when I was doing my PhD, worked with Microsoft for some of those works, right? There's a great story of collaborations and innovation coming from all parts of the world, the ecosystem. So I'll briefly touch upon some of the innovations. I can go on, like as long as you guys get hungry and go away, I can keep talking, but I'll try to wind up. But please ask if you want to know more about anything. I'm here tomorrow as well to talk. So what is the service that we operate? The database service, it's called Azure SQL or SQL Azure. We host millions of databases, which each database may run into hundreds of terabytes, or it could be small, big, whatever, all kinds of sizes. Last year, when we took that data, it was like 900 trillion queries per month, right? Now it's obviously probably exponentially more. That is the scale. We give an availability guarantee of 4 nines. Means the databases, the millions of databases will be up and available 99.99% of the time in a year. That means that in a whole year, we can go down for a couple of minutes, right? That's the level of guarantee. That's the SLA. If we violate it, it's like your internet connection. They violate, you ask for a refund or you go complain, right? So we give this guarantee. And yeah, we are available in all the regions, a lot of data centers, and we offer a fully managed service with all sorts of bells and whistles like automatic scaling, upgrades, backup. You can imagine the complexity behind this. Just showing you this data to highlight, right? While honoring all the compliance and data privacy. And of course, as I said, it's not managed by one person. We have a team of engineers spread across different geos, monitoring and making sure that we stick to our guarantees. And the basic mantra is never lose data, right? People put data in databases so that it doesn't get lost. So, but I can tell you it's very hard at the scale at which we operate. And again, it gives an opportunity also in the sense that there's a lot of data that we collect now from the data centers about how these databases are being used. And we use that for a lot of, statistical modeling, analysis, workload patterns, anomaly detection. You can apply all your time series data analytics to understand how the cloud the database service itself is being used and how you can improve it. So it's again a great space for research. And I'll leave you with one point about corner cases that I keep telling my team, that there are no corner cases here. In the sense, if there is a bug, if there is a race condition, right, that will hit, probably the likelihood of it occurring is, let's say, 0.0001, right? But at the scale of, let's say, 1 million databases even, we are at tens of millions or even more now. But even at the scale of 1 million databases, it translates to 1,000 databases, right? So it can happen more often than you think it will, right? So you cannot just wash away saying that it's very unlikely. It's a very low likelihood bug or a very rare occurrence or whatever. If one of those 1,000 databases happens to be Starbucks or Walmart or one of those big customers, Satya Nadella will get the phone call, right? So it's, you cannot ignore, which is where, we even go for things like formal verification, right? Can you prove the correctness, or can you prove that there are no race conditions in a piece of code, right? All those work that people do in the theory can have a direct implication in these sort of areas because it's super critical, right? And the scale makes it all the more challenging and interesting. Okay. So that's the kind of the glimpse of the scale at which the Azure SQL database service operates. It's one of the world's biggest database service, I can tell you that. probably the biggest. I don't have the numbers from Amazon, but I can tell you that from my knowledge, it is the biggest database service. Okay, I'll talk about a few recent innovations that came up from our group, and I'll leave you with that. So first one is the flexible resource allocation. So this is like, you can think of it as a packing problem at the heart of it, that you have a bunch of machines. You have, like, let's say I have 100 machines, I have 1,000 databases. How do you pack them onto these machines? Now imagine the same thing. There are 150 data centers, each with thousands of machines, and you have millions of databases to pack onto them with some constraints. What's the best way to pack? That is the problem of resource allocation. So that it's cost effective. We don't want to do static allocation, which implies a lot of high cost because you're reserving for each database fixed space, even if it is idle or not. Whereas flexible allocation is more of, you're trying to be more adaptive. So this is the classic problem of overbooking that people, you might have seen even in airline booking and everywhere else, that you over provision the resources. That if I have 10 cores, or if I have 8 cores on a machine, I will put databases worth 12 cores or 16 cores, because not all databases are active at the same time. You can actually more densely pack, just like how airlines do it, that there will always be some cancellations, so they will overbook the seats. So it's the same metaphor in the cloud, because we have to, the service has to be cost effective as well. We want to be able to run all the databases in as few machines as possible. That's how we lower our cost. So that's the heart of this problem. There are 3 papers I've cited here, recent one, the last 5-6 years, which have appeared in the top tier database conferences, which came from the work that we did, right? Again, I would encourage you to go look at it. And why I'm saying this is that the problems that we face in the industry, we solve them and then we go publish, and then academia picks it up and tries to further advance that, because we look at it from the industry lens, but there are obviously other ways to look at the problem and think about it more in a theoretical sense and so on. So it kind of sparks new areas of research, essentially. That's how we see the trends, right, across multiple problems. So this is one about overbooking and how do you do placement of databases and so on. So if you're interested in things like developing algorithms for doing these placements and things like that, this is a great area to look at. An extension is the serverless thing. If you have heard about it, there's what we offer, the database service as a serverless offering. You might have heard about serverless functions and such, where we take it even further, the auto scaling, like based on how your queries are using the resources, you either scale it down or up dynamically. So that's the recent paper that came out into VLDB. Right. Next, I'll talk about constant time recovery. So this is another problem. Okay, any questions on the resource allocation problem? Okay, so this is another, I'll quickly go over. Database crash recovery is a well-known topic of study. If there is while multiple transactions are going on, if the database crashes, let's say power goes down, when it comes back, it has to bring it back to a consistent state. You can't afford to have, the typical example is you reduce the money from one account, but before you add it to the other account, the machine crashed. You can't afford to lose that money. It has to either roll back, or the transaction has to commit, right? So that is called as the crash recovery problem, that when there are thousands of concurrent transactions touching like data points, data items, how do you recover from a crash? So but the challenge with the existing algorithms was that the recovery time was much longer. It used to take hours. So that resulted in an availability issue, because till the database recovers, it is not available. And as I said, we want to give 4 nines availability. If the database, there's a crash and the database takes 1 hour to recover, we have violated that guarantee and we have to refund. So that's that became a very important problem for us to solve. So in fact, we came up with the team came up with very innovative approach of combining, I don't know how many of you know ARIES. ARIES is a state-of-the-art recovery algorithm. and yeah, multi-version. Again, I'll skip the details, but we were able to bring it down to like around couple of minutes, right? So basic thing here is that it was proportional to the size of the oldest active transaction in the earlier technique, but we removed that. That's why we call it as constant time. So it is independent of the like how long the oldest transaction was when the crash happened. Anyway, happy to talk about all this. There's a paper again which has sparked a bunch of other academic work and follow-up work after this. There are all hardcore systems, operating systems, distributed systems problems, right? But yeah, it's at the core of what a database is supposed to do. So that's why I say disruption is happening at a very fundamental level. Okay, so that is that. Confidential computing. How many, I guess people who are working in this area will know about enclaves, which are these trusted hardware modules where the hardware is guarded, right? So you cannot access some parts of the memory, even if you are like the administrator or whatever, unless you have the key, and the key can be outside. So we are one of the first to leverage these sort of hardware and show that you can actually do what we call as always encrypted, which means the data remains encrypted while it is on disk, even while it is processing. When you're doing joins and all kinds of queries, it is encrypted. And even on the wire, it is encrypted. It gets decrypted only on the client where it's a trusted area, right? Trusted environment rather. So this is one of the like sort of the latest state of the art in the area of query processing on encrypted data, right? How do you process data without decrypting it? Right? The holy grail, of course, is the homomorphic encryption, but these are all ways to get to practically solve the problem. So there is a paper. Oh yeah, there is a paper on this as well in Sigmod. Please do read if you're interested. This is the recent one which we did about how we can integrate ledgers and the blockchain technology into databases, right? Blockchains are great for doing this whole tamper-proof log, right? But in terms of transaction throughput, they're very slow, so it's not practical to use them for high throughput, high volume transactions. But how do you get the best of both? Databases are great at doing transactions at scale, but they don't give you this guarantee. So now with technologies like these, we can start to get the best of blockchain coupled with the performance of databases. So again, please do read the paper. I'm going to skip to the end. This is my last slide, I think. Note, I say that nowadays no talk can go without mentioning AI. But yeah, so, and again, we are no different. AI is definitely disrupting all areas. And as you all know, Microsoft is sort of one of the leaders in the AI space with all our work with OpenAI and the Azure OpenAI service and so on. And so we have fundamentally also now working very closely to integrate some of these things in multiple ways. I have mentioned a few. One is the vector database support. Many of these intelligent applications, the next set of apps that will be built by developers, app developers, will be intelligent apps. They will have AI from the ground up, or they will be built with AI as a building block or part of every app, right? How do you make databases, how do you make these apps, building these apps easy? By providing those abstractions in a database, right? Again, very fundamental to what databases should be doing and bringing the AI, some of these technologies into the database. And co-pilots, the popular one is the natural language to SQL. The video earlier was showing some of that you can express your query in English or a natural language, and you'll be able to talk to your database in English rather than SQL. And there are multiple other co-pilots that you will see that, okay, if I'm troubleshooting, if I want to tune my database, configure all of those, if I run into an issue, troubleshooting, all of that are great areas for co-pilots to solve. And the other big area is what we call as autonomous database, or what is also known as self-driving databases and so on, where there is no need for a DBA. where in the database tunes itself based on as the queries and transactions happen. It looks at its own data and learns and tunes itself. So automatic indexing, automatic query optimization, auto tuning. So these are all, again, I'm just throwing out the names of topics which are actively undergoing research and innovation. Right? This is in the intersection of databases and AI. So I'll wrap up. I took maybe 5-10 minutes more, but key takeaways, just as an example, I took databases. This is true for many other areas, but there's a lot of innovation yet to be done. All the problems that I spoke about, they're not solved fully. There are a lot of open challenges still. And yeah, cloud has unlocked many challenges and research opportunities. And so I would conclude by saying that there is like plethora of interesting and impactful research and engineering opportunities across all, like as I gave you a sample, cryptography, formal verification, compilers, distributed systems, operating systems, algorithms, right? I already touched maybe 7 or 8 areas of computer science in my talk, but this is just a small glimpse. I can tell you, you name an area of computer science, I can tell you how deeply it is required or part of a service such as this one. So I would like to end with an open invitation to collaborate and contribute. If you're interested in knowing about career opportunities, happy to talk offline. We look for interns, software engineers, systems engineers, researchers, postdoc researchers, all sorts of all those roles, right? We have across Microsoft Research and Microsoft Development Centers in India and elsewhere. We do have openings across. And again, I just touched about databases because that's where I work on, but much broader umbrella in Microsoft. So with that, I'll conclude. Thank you. Thank you all for staying up, staying late. And I know I'm between you and dinner, but thanks for listening to me. Happy to continue the conversation over dinner or tomorrow. Thanks again. Okay, if there are questions, I can take them now, or we can, since it's already time, we should probably break for dinner. Please, let's head for dinner. Thank you. And tomorrow we have the keynote at 9:30. So let's meet again.